Jo, nu kanske syns det något på skalan. Ja, ja, men det blir bra.
jag kollar alltid att det är varje. Det här är också lågt batteri. Kanske kan be dem köpa lite nya batterier. Det här, alla verkar ha lågt batteri.
one works. There's a mute button here, but I don't know how it is supposed to work. Okay, and so you put this on your head and yes, I think
Testing, testing.
and then this
Tommi, laita.
I think you should remove it because we're just checking that it works.
Okay, so that
Let's-
one works.
Works. Check how to
Like this.
this.
Oh.
Okay, then you stick some of this somewhere on your board. Okay, let's leave them there.
Ja, jag skickade faktiskt in exot här i våras. Handledaren var nej, det här duger inte. Så har jag fixat det. Det är man ska fixa. Ja, nej, det duger. Det ligger i grisen. De vägrar inte säga vad som ska göras. Deras kunskap. Hela poängen med en handledare. Rätt telefon.
Är det fler på?
Jag och Daniel har varit. lite sur, men jag har lite service och grejer och
Ja, ja.
strular.
Vad är det som strular?
Den har en fin rand rakt över displayen där touchen funkar. Det som jag var inne på service då var i och för sig att accelereras. Det var en tjänst.
Det händer mig några gånger i veckan. Vad som är värre är att den ofta inte får lägga på luren. Jag tror att det har någonting med kind.
Yes. Det var ju spännande. Jag också alltså bara helt inte känner igen touch överhuvudtaget.
YouTube bryr sig inte om man stoppar streamen, om man stoppar den ett tag. Så att det tror jag gjorde det nyss. Exakt, så jag låter den rulla. Det stoppar bara. Det är bra. Men därför, jag var lite orolig för igår, så hade alla streamare från de andra rummen alldeles, men inte härifrån. Så här kommer upp en 9 timmar lång stream här från det här rummet i morgon. Så den här bara hade tagit jävligt för det. Second time. It's a national sport.
But I mean, it's to keep the students awake when they lean forward.
We do it on purpose.
It definitely makes you buy an SSD. So.
Yeah. This computer survived the trip across the Atlantic, so it kind of survived being thrown into
So we have to share it. Yes. I think I can find another one. But I think that is just okay.
Båda två eller?
Nej, på en tror jag är full.
Om man byter ut den. Ta inte den vänstra, den är trasig.
It was low 10 minutes ago.
This?
Yes, this.
Now it's full. That doesn't make
Is it
sense.
full?
It says it's
Yes,
full.
it was green here. So, okay, let's start. Let's start. Hello and good morning. Let me introduce you Tommy Pernilla and Arthur Johnson, who will be talking to us about attacking FreeBSD network protocols, why, how, and the results. Let us greet them.
Thank you. Good morning, everyone. So we're going to discuss a little bit about FreeBSD networking. Let's see, I pushed this button. Yeah, it works. So a little bit about us. So my name is Tommy Pernilla. I do kind of security consulting stuff on Nixu, and I've been playing around with InfoSec and telecom stuff. So that's all of those really weird SS7 protocols since about 2006. And I do a bunch of different kinds of security consulting, and nowadays one of the interesting public things I can discuss about is this 5G security architecture on this 5G Ensure working group.
And my name is Arto Jonsson. I work at Nixu as a security specialist. I've been involved in open source projects since about 2006, worked in several projects, started my own. I have some very minor contributions to OpenBSD, and as a side note, if you're interested in computer chess or creating your own computer chess AI, you should check out this project that I've been working about 7 years now with a friend of mine, and it is very neat if you're interested in this topic.
Okay, then probably most of you haven't heard about Nixu, so it's a pretty old company from a kind of IT perspective, but maybe not for you, Paul. So around 88, do a bunch of things in multiple countries, and we have 140 people that only do InfoSec relating stuff, and then we have some managers and administration people on top of that. So actually pretty large on the Nordic countries. Here's a bunch of certifications and abbreviations that you security people roughly have an idea what we do. So we pretty much like consult, implement, and audit different kinds of stuff. So point of this talk is to first discuss a little bit about fuzzing, what it is, how it works, and then we kind of roughly take a look at what kind of tools they're usually used for fuzzing, at least what we've been using. And then we have some test cases on the FreeBSD network side. And then we take a look at what was happening.
So how we started this project? It actually goes back to fall 2013, and it started with a hike to northern Norway. And it was in the Staprodalen National Park, week-long hike. And I was part of, I think there were a total of 50 hikers, and we were divided into 4 or 6 of people, and we were hiking around the area. And I haven't met the 4 people that were in my group, and then we discussed about work-related things, and it turned out that a guy in my group was working for this company called Codemicon. And what they implement or develop is protocol testing tools. So the idea is that if you have implemented a protocol, for example IPv6 or something like that, then you run this tools against the implementation, and you get findings of issues in your implementation, and then you can fix them. And while we were enjoying the view, I got this idea that, okay, maybe this protocol testing is something I want to test on open source operating systems. And it turned out that Codemicon themselves don't do that much testing on like open source projects. They have some limited scale testing on SSH, for example, but not so much on operating system in general. And since I was spending my time learning about BSDs, I thought it would be a good idea to test something like this. But I was quite naive at that time, because I was thinking that, okay, if I work some company, we can just get these tools and then start testing. But it turned out that there's huge licensing issues and complications that you can't just go and do it with these tools. And fast forward a year, the guy I was talking with actually was one of the people who discovered the Heartbleed issue. So it's a small world.
So roughly what we were doing is that we took a look at all of different protocols that FreeBSD is supporting, and then selected a few of those, and then tried to find bugs of those, and then we tried to reproduce those test cases to make sure that we don't get some false positive, and then communicating these issues to the relevant developers. So also a little bit about our testing environment. First we're thinking that, hey, we have quite a lot of capacity on our intranet at our office. So we're thinking, hey, let's do this fuzzing in a virtualized production environment. So it turned out to be not really a good idea. So there's multiple problems with that. So first thing is that if you're trying to test a virtual server running on a hypervisor, usually the hypervisor doesn't like it so much that you're sending in like hundreds of gigabits of weird packets at it. And also we're saturating pretty much all the network interfaces, and also our IT department wasn't really happy when they heard about this thing. Like, okay, maybe it's better to do it that way. So if you're some point that kind of thinking about testing network interfaces, you need to use real hardware. So this is our real hardware, really high-end stuff. So some ThinkPads, laptops. So we have then FreeBSD 10.1 running on it, and then we used a bunch of different operating systems with a bunch of different tools, and then used just a dumb gigabit switch. So also earlier on we were a little bit discussing and think that what kind of FreeBSD version we should be taking a look at. 11 would be interesting, but problem is that some of our test cases are really, really long, and current keeps on moving so much, so we decided to go with 10.1 release, which was the latest one when we started this whole thing. So, then about how did we select what we're going to test. So, in the beginning we started to go through system net directory, looking for all kinds of fun stuff that what would be activated. So we found this one file in.h. So has a bunch of stuff, but what is most interesting is that it contains the IP header protocol numbers that are basically capable of accepting in the kernel. Of course, that doesn't only, we need more than that, so that just means that those are supported, but we'll still need a bunch of protocols on top of that. So here's like some selection of that. So we have some historic stuff like X25 support still in here and so on and forth.
But not necessarily implemented.
Yeah. So we decided to then test FreeBSD, pretty much everything that's on the base network base
System.
base system, yeah. So we decided to kind of divide it into two different parts. Whatever is implemented on the network stack and what is then running as network daemons.
And we decided not to test SSH or bind or...
Because we're kind of assuming that many people have been testing this. So we were just... So we were thinking about, okay, a bunch of different protocols, how to narrow down the selection. So of course we need capability to test it. So we didn't find any shops that sell ATM or X25 switches. So we're not going to test those. So maybe like, okay, some protocols that have been having issues that maybe hasn't been tested enough, and some weird telecom side protocols. So this is roughly the main stuff we came up with. So looking at SCTP, Stream Control Protocol, very heavily used on the telecom side, and we'll be discussing of all of these different cases roughly, that what is the idea behind it and what we did.
SCTP was the main target in this because it's telecom, heavily used in telecom protocols, so that's what we are interested really. IPv6, because implementing IPv6 is very complex process, so there's got to be bugs, and these two userland protocols, just because they were relatively easy to test.
Okay, then a few words about fuzzing.
So fuzzing is really about testing the implementation by sending random stuff against it. So it's not an attack itself. So how it differs to, for example, code analysis is that we are testing the running system, and there might be some dependencies between different components in the system. So that's how, when we are testing the running system, it's different than code analysis. And there is different types of fuzzing. So with white box fuzzing, you take advantage of the fact that you have the source code. You can make some instrumentation based on that source code, compared to black box fuzzing, that is basically just shooting those payloads against the system and then just seeing that if it crashes or not. And they're all sorts of interesting things that can happen when you fuzz a system. Usually it ends up in denial of service happening. So how the process goes is that you start sending this malformed data. If it crashes, then you do some instrumentation, monitoring what happened, and then you try to find the root cause that causes the denial of service, and then you analyze the finding more, and then try to make it crash again, and finally you try to build a reduced test case, and that will be the exploit.
So when you guys are doing that, are you sending one bad packet, then testing to see if it responds, and then trying the next packet? How do you correlate?
Yeah, we'll get to that in different tools. This is kind of a rough overview about the different tools we've been using. So we have first Scapy, which is kind of a really cool Python framework that you can do interesting stuff with. Then the Codemicon Defensix that Arto was discussing about, so very big commercial fuzzer. Then we have AFL, which is a very cool fuzzing tool for white box environment. And then we have Verdamsa, kind of a very simple black box fuzzing tool. And then we have a PyFuzz, which is kind of another framework built on Python. So first, some details about SCTP. So it's a layer 4 protocol like TCP, supports, gives reliable transfer for the user data on top of it. And what is kind of different between this and TCP is that in TCP, if you lose multiple packets, everything stops. And in certain cases, it's like really terrible thing that traffic stops. So SCTP gives this feature called streams. So you could have, for example, 10,000 streams. If one of those streams stop, only that particular stream stops, all the other ones keep on working. And also from the protocol kind of a handshake point of view, it's a little bit more resilient against denial of service attacks. So your basic SYN flood type of thing doesn't cause issues. And also it supports multiple IPs and interfaces. So it's built to be much more kind of resilient than TCP. So here's a kind of a basic idea that we have an SCTP association over the network to another part. So then we have two interfaces and IP addresses which are in different networks or VLANs. And the idea in SCTP is that one of these interfaces is in active mode while the other one, or there could be multiple of these, are in standby mode. So all the data actually goes just in the active one, and we keep on testing the standby with these kind of heartbeat messages just to make sure that it is up and running. So if for some reason the data connection drops down, then it switches over to the standby connection. And this is all kind of hidden away from the application. So if an interface goes down, all of that, application doesn't know about it. It just thinks that, hey, data is working. So it's really cool like that. So supports two or more network interfaces, kind of compared to TCP, has a two-way handshake with flags. So in SCTP we have four-way handshakes. And also to note that in TCP the handshake happens in flags in the TCP header. In SCTP we have kind of these dedicated messages for each of these packets, which means that there's going to be a whole lot more information in these packets. So as I said before, the stack doesn't actually allocate any resources until the connection is actually running up. So need to be having quite a few packages going backwards and forwards before we actually create any data structures on the kernel side. So small walkthrough of how the connection is working. So we have app 1 connecting to app 2. So it first starts with the app saying that, hey, I want to connect to the other application. So SCTP starts opening up the connection with an init message. Server then responds, and in the response we have a cookie, which is kind of a 260 bits or so amount of some gobbledygook data. So then the client side gets the cookie data, sends it back on this cookie echo message, and then the server verifies that this cookie is the same one that we sent. And also in these messages we have sequence numbers that need to be matched, and also we have these identifiers called tags. So they also should be matching. So quite a lot of parameters that need to be matched up. And only after this point we start allocating resources on the server side. So after all of this, then we can start sending data across the connection. So then a bit more details about this Codynamicon tool. So there's the website for even further information. So this is a commercial fuzzer. So what is one of the reasons you want to pay money to get a fuzzer? Because there are some open source ones available. Well, one of the biggest one is test cases. For example, for TCP there's roughly about 1 million different test cases that all of different things that could go wrong and all of that. And there's also very nice tools to way to monitor the connection, seeing real-time statistics and rerunning the case, and there's kind of a pretty nice user interface, and you can fine-tune things quite much. But of course, if you have so many features, it also means it's quite complex and it requires quite a lot of resources. So here's just some slides to see the user interface. So basically, oh, it looks like really beautiful. Okay, it doesn't matter. But basically just put some authentication that, hey, I want to test this IP, and if you have username and password, put that in as well. And then you basically just click, let's go, and select that do you want to test like 1,000 test cases or 100,000 test cases or million. And after you run it, you basically get this huge list of like, okay, all of this went through, but one of the test cases actually failed, and you can like see it, and then in here you can imagine that there's like lots of fancy details in here about like what was actually going wrong. But you can go to the EuroBSDCon YouTube channel. There's some videos about it, how it works. So, bit more technical stuff from SCTP. So about the state machine. So we're starting from the closed point of view on the client side. We're sending an init message out. Then we're in a cookie wait state. So this is kind of coming from the RFC. Then we are receiving this init awk message. So then now we're in a cookie echo state. So then the server sends us the cookie acknowledgement. So now we're in established state. And if we want then to stop it, we could then go to a shutdown process, which is a three-way handshake. And similarly, if at any point the client wants to do something to stop the connection, you can do it with a single abort message. Similarly, from the server side point of view, we don't have any state otherwise than closed and established. So from the server point of view, when we received a cookie echo that is valid, only after that we go into this established mode. And similarly, when we are in this established mode, then we have the capability of sending these heartbeat messages or sending data or selective acknowledgements and all different kinds of things. So what we were doing in our testing is basically, this is the way the model should be working, but when, for example, we're in an established state that the server has allocated some resources, we're then sending different kinds of messages. So we are sending like init awk message to the server, which is supposed to be coming from the server, and trying to kind of break the state machine of the server implementation. So, how to do this? Well, EuroBSDCon also will do this kind of thing, that it will then send messages out of scope, but of course you can do it with other tools. So Scapy I mentioned before. There's a website, you can download a copy of it. So basically it's a really nice Python framework where you can manipulate network data. So it works on layer 2, 3, and 4, and has this kind of a very nice syntax that you can define only those parameters on the network stack that you're interested in, like I want this packet to go to this IP address. And then there's some other fields in there that I don't care, so Scapy will then fill them out so they have some roughly correct information. For example, Scapy will calculate all of the checksums for you automatically. So some basic examples how it looks like. So we have send p function. You can define that, okay, Ethernet level, all the default options. So source and MAC address. IP level, we want to go, for example, to local. Loopback interface, we can define TTL values, we can define an interface going out, or we can loop the message sometimes, and what is the interval of the loops, or we can like input pcap files and send it out. And also in Scapy, there's a fuzzing parameter inside. But it has some limitations, so if you, for example, here fuzz the contents of TCP, it will then take a look at, okay, in TCP header we have, for example, source port parameter. So we only have a fixed amount of range, what data we put in there, so it will then act according to what is the field length and what kind of data will go into the field. So then you'd have some random data in there.
So in this example, we have explicitly set as a source port and destination port. So these are not randomized in any way. And
if we don't define something, then it's going to be something random. So here's kind of a part of the Scapy script that we did for SCTP testing. So importing some stuff in the beginning, and also we're taking a look now that this abort part, that if we are receiving at any point an abort from the server side, we basically then stop the testing.
or we are testing the packet if it's abort, and then we use it later to check whether we should stop the testing or not. There's the fuzz function that we saw in the previous slide. So there's quite a bit of limitation how the fuzzing in Scapy works. So it fuzzes only the values. So we are interested also in the state. So instead of just the values, we want to also send out of state packets.
Yeah, and similarly, if there's some kind of a timeout, we don't get a response from the server side, we then want to kind of save these packets that we sent
For later processing.
And then we hard code some parameters, and then you can first ignore the top part. So then we have the init message, then we have a structure for that, how we can get the first message going up. And then we have our init ACK, which is the message coming back from the server side. And then we have send and receive one function. So then we get some parameters from the init message, including tag information and so on and forth. And also from that message, we then get the cookie from the server side, which we then put in here into our cookie echo message. And then we get some parameters back from the cookie ACK message. And also because we managed to find quite a lot of bugs and features that are not supported from the SCTP point of view in Scapy, we needed to hard code quite a few of these things. So for example, on SCTP init packet, you see that there's quite a lot of parts that we needed to hard code. So hard code all the things. Then we have here then our actual test cases.
So we basically just created different types of SCTP chunks, then use the common part and concatenate the fuzzed chunk to that, and then we send that the wire.
So basically some out-of-state packages, or when we are having the connection up, then the server side is expecting, okay, now we're going to receive a kind of a normal type of data packet, but then we select, for example, and send 65,000 zeros to the other side and stuff like that, or just send some random stuff. So then we had some problems that we needed then to have a target that's basically working on the FreeBSD server side. So we needed to code of like really dumb client, well, really dumb server software that basically just opens up the socket and listens for some data that comes in and reports some information for us, so we can monitor that is the server running correctly or not. Also, we found that there are interesting bugs or kind of features in implementation of some of the tools we've been using. So,
I'll come back in a minute. Oh, now the battery died. Please.
So when we hit some issues with the SCTP implementation in the kernel, we started to read the source code and enable some debug flags. Unfortunately, it is very complex code, so even with adding these flags and adding more information printed out, we didn't still were missing information what went really wrong in the system.
Yep. So we basically turned all of the debug flags we could find on SCTP side, recompiled the kernel, but still in some cases we could not figure out like what is actually going on. How come it's not opening up a connection? And similarly in dtrace, there's not enough pointers or probes for SCTP to actually monitor that what is going on, how come we are not reaching that state. But maybe this is just because that SCTP is trying to be kind of really resilient against denial of service attacks, so that's why it didn't like work nicely when we tried to send like bad data to it. And also looking out from RSC 4960, restrictive implementations of SCTP may send back an abort chunk in response to an init chunk. So if we send some kind of a message that the server side doesn't like, it can basically just say that, okay, I don't like you, abort, I drop the connections. So this is, we've been seeing quite a lot, that we're sending a whole lot of data and we're just getting aborts back. And of course in the spec, if you send an abort, you could kind of put information, how come you're stopping this connection, but of course all of these are abort because of empty. So we had quite a lot of issues with Codenemicon working with trying to get the fuzzing working and opening up the connection. So one of the things we've been thinking that might cause the issue is that on the Codenemicon version and FreeBSD version, maybe they're implementing the different RFC, maybe they're using different these extension parameters inside of the message. And that may cause some compatibility issues. And we actually spent the whole day working with Codenemicon guys in this kind of a, what was it, crash day or something like that?
Crash test party.
Yeah. So this kind of a fuzzing day sponsored by Codenemicon, and tried to get the whole thing working, but no, it did not work. So most of our time was kind of focused on trying to break this protocol. On the FreeBSD side, despite all of our efforts, we didn't manage to cause any kind of meaningful result. But the kind of beginning idea is to kind of start testing SCTP implementation, as some other OSs have been having some quite big issues with SCTP because it has so much more functionality than a TCP connection. But suppose you guys know what you're doing when you're creating the stack.
So we quickly looked at IPv6. We didn't do much, barely scratch the surface. We have seen in our own testing with our customers a lot of issues with IPv6, even in 2015. Some of these more common issues are related to fragmentation and neighbor discovery, whereby, for example, you create a set of fragments that have holes between them, or in neighbor discovery, you start flooding the network with certain type of advertisements. These are old attacks. These are known years ago, but still 2015 we have seen them, unfortunately. For IPv6, we use this THC IPv6 attack toolkit. Open source, it's a collection of tools basically testing vulnerabilities in IPv6 and implementation issues. There is a tool for creating invalid fragments, flooding attacks, everything, basically everything you can think of. And when I said about these attacks that they are known and old, what we actually observed in FreeBSD in two occasions was that we were able to completely freeze the target system using these router advertisement and neighbor solicitation tools that are in the IPv6 attack toolkit. We were able to repeat this several times on 2 separate installations, but not after that, unfortunately.
Yeah, using the same hardware, using the same switch, the same cables, on 2 installs we managed to freeze up the system multiple times, and then we reinstalled it again. We could not do it, and we then did the reinstall like 5-6 times after that, and didn't work. So, well, we can discuss the details a bit later on. But with a 100 meg connection, system completely froze up, and with like 10 meg connection, you could get the CPU utilization very, very high on the system.
But no effect whatsoever, basically. But on 100 megabit connection, we were able to froze the system completely. So then about these other tools or other protocols that we tested, basically we took the 2 diamonds that were are present in the base system, and we put them into AFL. So American Fuzzy Lob is a fuzzer. You can use it mostly in white boxing, but there's also a black box fuzzing functionality. It is very sophisticated because the functionality is based on compile time instrumentation. So you compile the program with the compiler frontend that is in AFL, and it inserts instrumentum points into your application, and based on this it creates these test cases. So there's examples in the AFL webpage where AFL has created these JPEG images based on only the information that has been in the code, so it is very sophisticated. So this is just basic usage, how you use it in non-network programs you want to test. So you compile your program with the AFL provided frontend. You provide some initial test case. It can be a valid test case. So there's no need to do any initial fuzzing for the input, and then you just run the AFL fuzz against your program and provide the findings directory and test case directory. Then you wait, depending on how speedy the fuzzing is, about 30 cycles or so. I think that is the recommended, and then you see what the findings are and try to replicate them. So this is AFL. What you're mostly interested about in this user interface are the cycles done in the upper right corner, and the total paths. So this is the unique paths that the AFL has discovered in your code, and the coverage in map density. So you want the code coverage to be as high as possible. So what about networking tools then? So if you think about packet processing, it is basically just reading a packet from a network, processing it, and then maybe storing a result, sending a reply, and then repeating it. So we modified these 2 daemons to fit AFL so that instead of reading a packet from the network, they read it from the standard input, then they process the packet normally, and then we exit. So we are trying to focus the fuzzing on the processing the packet. So we want that to be the fastest fast code. So we modified the diamonds. There were several potential issues. So AFL reported that yes, I have discovered a hang in these diamonds, but unfortunately, when we later tried to analyze these tests that the AFL claimed that they result a hang in these diamonds, they were false positive.
But that way, it's good that it doesn't hang. Then we have some additional tools.
We have about 5 minutes left, so I think I'll skip the biofuzz, but just like a quick overview of Radamsa. So it's basically a black box fuzzer. It has some capability to work basically with any file, so it has some understanding. So the idea is that you feed input to Radamsa and then it spits out a fuzzed output. So it has some capability to understand the input, but basically it is created in such a way that it doesn't have to know anything about the input data you are putting in. So it is very easy to use. So you can just, it creates a binary file and you can feed some input to Radamsa, and Radamsa will read a random number from the operating system, and based on that random number it will generate a fuzzed output. So from that last input we can see that there is that Radamsa has a capability to have some understanding about the input, so it doesn't just output a string, it actually modifies the number itself. So then there's some parameters you can control the input, and if you run this last command, it will probably hang your BC. That is, I can almost guarantee it, because this will create a 10,000 line long fast input and feed it to BC, and most likely it will hang. So I think we'll skip by fuzz. And then about OpenBSD.
Hey, Henning woke up.
So we were mostly focusing about FreeBSD, but then on one weekend I decided that okay, we have this testing set up, so why not just test some OpenBSD stuff. So I picked HTTPD because it's relatively new. It's based on text protocol, so you can create very evil test cases. And then after running the fuzzer for a night, I noticed the next morning that okay, HTTPD is no longer processing any requests. So it hadn't crashed, but it just wouldn't reply anything to GET request. So after some analysis, I found out that it had actually exhausted its file descriptors. So I was able then to create a reduced test case whereby you send a specific type of GET request to HTTPD, and it will actually hang the connection in such a way that it doesn't release the file descriptor. So if you then repeat this request over and over again about 500 times, then HTTPD will be dead basically. It will be running, but it doesn't process any request anymore.
Then we were discussing about, okay, that if we then want to kind of expand our research project, that what we could then do in the future is that maybe try to learn to use dtrace. I've been talking with some people to kind of that how we could add more probing stuff on SCTP level to check what are the states and what is actually happening inside of the kernel. and also like maybe taking a look at a bit more for other BSDs and maybe start poking around current at what's happening. And also maybe to kind of do some instrumentation on the kernel side, but I'm like a really crappy programmer, so probably I'm not the guy to do that. And also another protocol which is very interesting, multipath TCP, which is actually being used, for example, in Apple iPhones currently, but it's kind of relatively soon coming to all operating systems. So it has some interesting signaling that takes place. So there's something that might be interesting to test at how this can be kind of exploited, that what could go wrong in the signaling. And also, we should probably take a look at how VNet virtualized stacks in FreeBSD, that is there any difference on native stack compared to a virtualized stack. And then some thanks to Antti Husa, Ivari Korhonen and Alexei Petranko, some Nixu guys, and Antti Husa has kind of did this PyFuzz fuzzing framework. Okay. Thank you. So maybe we have some time for questions. Yes.
This OpenBSD HTTP problem that you found, did you report it to the developers?
Yeah, question was about OpenBSD developers getting notified that, and
Yes, they have been notified.
was it?
I think I sent the original email about the problem 2 months ago.
So, any other questions? Yes?
Will you continue doing this? Is it worthwhile?
Probably, but I don't know how much time we can allocate as we have like a bunch of other things. But as a hobby, at least, I will continue doing this. But
I'm actually thinking about continuing this fuzzing research with USB. So we have ordered USB fuzzers, basically devices that you can program, and then you can create like fuzzed traffic to USB. So that's something worth researching, I think.
what could go wrong? Any more questions? Comments? Yes?
From all the fuzzing tools that you use, which one would you prefer? I know that one is commercial and has all the test cases, but the other one.
So the question was about which fuzzing tools we like the most. Well, it depends totally on the case. That, for example, if you wanted to do this network diamond testing, you need to then use something like AFL or Redamasa. But if it's on the network side, then it's you use the correct type of tool for the correct job.
The problem with Codemicon is that it has static test cases. So they have created this, TCP has like 1 million test cases, but they are not created based on the code you have. So the advantage of AFL is that it creates the fuzzing payloads based on the instrumentation in the code, compared to Codemicon, which just sends data based on the test cases that they have created.
So in a way, maybe you get more intelligent testing. But any more questions?
How much of this could you package up in script so that it can go into the build farm as just normal, constant background testing?
So the question was that how we can kind of automate this thing, then script everything together. Yes, it's possible if you have known that I want to test these specific protocols and you have some kind of a logic specific for that protocol available, then it's possible. But like for AFL, you need to have some instrumentation in the code, and
I I would say it depends on how the code is organized. If for example, the packet processing is very well separated from the main logic of the program, so you can just take that packet processing code and then create some simple application that only calls that code and then feed that to AFL, then I think that would be relatively easy to create.
Any more questions? Okay.
If no more questions, you know what follows?
Akavit? Okay.
The famous Scandinavian bread.
Okay.
So you have to share it.
Yeah. Okay. Thanks. Yes.
talk, and I'll,
Yeah.
I can switch over to another one if.
Yeah, you'll notice.
Yeah, it's like this way. But do you first want to like do an opening word or something, or how does it work?
I will introduce you, but I don't have one. I can speak loud.
Okay.
How do I pronounce your second name?
Schouten.
Schouten.
Yeah. Oh. Test 1, 2, 3.
Okay, so let me introduce you. Ed Schouten, who will be talking. It just doesn't work, so I will try to be loud, and I'm just introducing the speaker here, who will be talking about the Cloud ABI, and let's greet him.
So before I actually start my talk, Gavin Atkinson asked me to sort of convey this message to you. There's a PGP key signing party in the red room during lunch. So don't grab any sandwiches, go sign PGP keys. So with that, I'm going to start my talk about Cloud ABI. Before I actually explain what Cloud ABI is, let me first sort of explain to you what sort of bothers me about Unix. I've been using Unix for the last 10 years or a bit more even, I think. But what I've noticed over time is that there are some fundamental problems in Unix that don't really seem to get solved. One of those problems, in my opinion, is that it doesn't really stimulate you to run software in like a safe and sandboxed way. You know, every couple of years you see a new security framework pop up, and then after a couple of years, people stop using it because it's too hard or doesn't really work that well in practice. Yes, which will also be deprecated in a couple of years from now. Also, the problem is that it doesn't really stimulate you to write code or programs that are reusable and testable. And I'll demonstrate later on, like, why that is. And also what I've noticed is that systems administration doesn't really scale. So you also see that every couple of years there's another piece of technology that's supposed to make this easier, jails, Docker containers, Xen, KVM, but they don't really seem to scratch the itch that people have. So now to sort of explain these problems in more detail. So if we take a look at a rather simple piece of software that a lot of people run. Say you want to service HTTP requests that come in over the network. You want to run a web server, and this web server should only be capable of performing a very small number of actions. So first of all, it would only need a TCP socket on which it's receiving incoming TCP requests, parse the request, figure out which files needs to be served, and it needs to serve the file from disk. So it needs to have access to a directory in disk containing the files that need to be served across the network. More advanced web servers typically also talk to databases. You know, they have a TCP socket or a Unix socket open to a Postgres or MySQL instance, for example, that they need to talk to. These are the only three things that a web server typically needs to do. But in practice, you see that if there's an exploit in a web server, say a buffer overflow, and an attacker is capable of sort of taking over the control flow of the application, that person could in theory just open a TCP socket to some kind of random server on the other side of the world, create a tarball of all world-readable data that's on the disk, and send it over. And sending over world-readable data is typically not a huge problem, but it does leak a lot of properties about the system in general. You really need to know that all the permissions on disk are properly set up, that this is really not a problem at all. And you only have a single line of defense in the end eventually. So what this attacker can also do is, at least on FreeBSD at least, run the cron tab program, add an entry to the cron tab of the Apache user, and even if you sort of eradicate all this malware that was installed on the system, a couple of hours later the attacker can still spawn up a new process that does the same thing, at least on FreeBSD. What it can also do, it can use setuid tools on the system to do all sorts of annoying things. So for example, it can invoke the write command on FreeBSD to spam messages to everyone's terminal, and in the worst case it can turn your system into a botnet node that does, I don't know, Bitcoin mining or spamming or all sorts of annoying things. So one of the solutions to this problem that you see in Linux land is AppArmor. Who knows AppArmor in the audience? Yeah. So AppArmor is basically yet another access control system where you sort of create a profile of what an application is allowed to do, and the program is started up with that profile in effect. So you can sort of say this web server can only access these paths on disk and read files from them. What I see in practice is that because this is a separate policy that is in no way integrated into the application, you see that it gets out of sync really quickly. So, for example, a web server, as soon as a user tries to add a virtual host to the Apache configuration, for example, that tries to serve files that are not stored in like the web server root directory, that policy is already broken. You need to make exceptions to the policy. And what you see in practice is that people are just too lazy to fix up those policies, or they simply don't understand how those policies work in the first place. So more novice users, in the end, they just tend to turn off AppArmor because it's the only sane thing they can do in that situation. It really puts the burden of securing an application onto either package maintainers or end users, and I just think that that's a really bad paradigm. So in FreeBSD land, there's another technique that appeared, and it's called capsicum. And what capsicum does, it sort of introduces a two-state model where programs, they sort of start up like regular traditional Unix programs that can access all files on disk. They can create network sockets, maybe even perform actions that are normally restricted to root if they're started up with those credentials. But after some time, after they've acquired all the resources that they need to continue their execution, they call a single function called capenter. And capenter effectively turns off access to all global namespaces on the system. So you can no longer create random TCP sockets and make a connection to another system on the network. You can no longer open arbitrary files, but there are still a lot of things that you can do, namely accept incoming connections on a TCP socket that you already have, or if you happen to have a file descriptor to a directory, you can just open files that are underneath that directory. And over the last couple of, Capsicum is only part of FreeBSD 10, I think. It was already part of 9, but only enabled in 10. And you see that over the sort of the last years that the use of Capsicum is increasing. A lot of core utilities in FreeBSD are using it. So Capsicum is awesome. In my opinion, the other BSDs and Linux should also add this, and there is some work in that direction. So there is a patch set for Linux to add Capsicum, and some people at Google are trying to push this in. There are a couple of disadvantages that make Capsicum a bit hard to use, and sort of the largest one I stumbled into is that suddenly disabling a whole bunch of system calls does break a lot of applications. So the worst example that I've seen is in the cryptography library that I installed from the FreeBSD ports tree. If you just use this crypto library in your FreeBSD system, it uses high quality entropy. But as soon as you call capenter, it can no longer open dev urandom. So what it does, it calls get time of day and get PID, and uses that as the sole entropy for the process. So you try to make your process more secure, but by sandboxing it, you actually make it insecure. So it was called libtomcrypt. You asked for the name of the library, it was called libtomcrypt. That's like a tiny crypto library that's used by the drop bear SSH daemon, for example.
The root issue here, of course, being that it even has that fallback code.
The remark was, so the root cause is that this code is already there. Yes, exactly. And later on, I'm going to, when I explain what Capsicum is, hopefully you'll understand that Cloud ABI sort of fixes this issue, but I'll describe it later on. So what I've also seen, could you repeat the question? The question is, how does it stop programs from being stupid? Well, just wait for a couple more minutes and I'll give you the answer to that. So I've seen that FreeBSD's core libraries also suffer from this problem. So, for example, if you call capenter, then you can no longer access the time zone database in your application. You can no longer use locale information. So, in my opinion, you can't actually use Capsicum to build these really sort of rich applications that have a lot of features, because a lot of core functionality already sort of implodes. So what I've noticed is that Capsicum also really doesn't scale. So the examples that I provided on the previous slide, these are all just really tiny applications. DH client, ping, SSHD. Well, SSHD is moderately complex, but sort of really compare this to, say, running Nginx or any of those applications. We don't see any adoption of capsicum in those applications. And I've noticed that the reason for this is, as the application gets larger, it becomes so hard to deal with that issue of, features suddenly being disabled. Applications start failing in the weirdest way. When you try to sort of port an application, say if I would port Nginx to use capsicum, I would, in a place where I think it's sane, I would put a cap enter call to sandbox it. A lot of things would explode, and I would need to spend the next half a year debugging issues to get Nginx to work. It really doesn't scale for larger applications. So sort of a segue, another Unix security problem that I've observed is that Unix generally doesn't really allow you to run untrusted applications safely. If you would just download an arbitrary binary from the internet and just run / whatever, that could really mess up your system in really bad ways. And running those programs securely is pretty hard. So even if I would put these files in a jail, they couldn't easily access the other files on disk, but still they could open arbitrary network connections or spawn processes in the background to do all sorts of scary things. There isn't a simple way where you can just say / my program and run it safely. So enough about security. Another problem that I experience is that that Unix doesn't really make it possible and make it easy to write testable, reusable software. And for that, we're going to look at a different programming language for a second, so not C, but we're going to look at this language called Java. So say I would write a really simple web server in Java. I would write a class like this. This is obviously not a complete class. It misses the implementation, but we're just looking at the constructor for now and sort of some of the private members. This web server is obviously not reusable in any way. I can't even run two of those web servers on the same system, simply because they both try to bind to the same TCP port. So a Java programmer would typically write something like this, where you parameterize the port number and the root directory. And now you can actually reuse this web server. You can spawn multiple of them. But then a more veteran Java programmer comes along and he says, no, you have to write it this way. You have to use so-called dependency injection, where instead of letting the class create a TCP socket and letting it bind and access the file system itself, you have sort of opaque objects on which you call functions to do the actions for you. This is what dependency injection is, and this is what makes software testable. So Unix programs are a bit like this. They either hard-code certain attributes, how they should behave, and if they don't, they hard-code path names of configuration files where they can find attributes of how they should behave. And the resources that the programs use, they're acquired on behalf of you. You never provide the resources that the processes use manually. And this is, in my opinion, a double standard. If we really care about, the last couple of years, you really see that people care more and more about software testing, and they really focus, a lot of the effort is going into making object-oriented code more testable, but we're doing nothing towards making programs as a whole more testable. So this is an example of a very simple web server that is actually testable. It is possible to write these testable applications on Unix. It's simply that nobody does it. This is a really simple web server that just prints the same message back across the socket. But what it does, where it's different from most traditional web servers, is that it uses standard in as a network socket. And this... sorry, what was the question? That idea isn't new, was the remark. Yes, exactly, that idea isn't new, but you don't really see that pieces of software currently use this method. And that's a real shame. So this web server is reusable. It can use IPv4, IPv6. I didn't write a single line of code for this. I can pass in sockets that have custom socket attributes set up, custom timeout parameters, custom retransmit parameters, without changing a single line of code. I can even spawn multiple of these processes at the same time, and suddenly I just have a concurrent web server without writing a single line of code. And this web server is testable. I can just provide it a Unix socket, and I can programmatically send it requests and capture responses. So now I'm going to describe what Cloud ABI is. In my opinion, opinions might differ, of course, it is a Unix environment in which software is easier to sort of sandbox against exploits, and it's also an environment in which you can write software that's easier to test. The eventual goal of this environment is that it also becomes easier to just maintain software at a larger scale, and later on when I'm going to discuss some of the use cases, you'll hopefully see that this is the case. And in practice what it is, it's just a POSIX-like runtime environment plus the Capsicum programming interfaces and some of the extensions that were introduced as part of Capsicum, minus all of the stuff that's incompatible with it. So processes already start up in a sandboxed mode. There is no open system call. You can no longer open an arbitrary file on disk. You can only open files relative to a handle that you already have. So the default rights of a process are really simple. If you just run /myprogram, this process can allocate memory, it can create pipes, it can create socket pairs, it can create shared memory. In essence, it can perform IPC. It can create sub-processes, it can allocate memory, it can interact with clocks, all those sorts of things that we know that are safe and have no impact on the system as a whole. Processes are really just confined. This is of course not enough because you want processes to communicate with the outside world, so what you do instead is you start processes up with a set of file descriptors. And these file descriptors, they actually provide the functionality. So you can provide file descriptors to directories to grant file system access and sockets to grant them access to the network. Unix also provides support for passing file descriptors across sockets. So this really allows you to do privilege separation. So the web service that I mentioned earlier during the talk, you can easily model something like this in Cloud ABI by having a single process that needs to be started with a single socket for HTTP requests, a single file descriptor to a directory containing all of the web server root files, and a single file descriptor pointing to a log file. And you can be certain that this process can never access anything outside of these three resources during its lifetime. So another thing that I observed while I started hacking on this is as soon as you sort of start to take POSIX, add Capsicum, and rip out all of the things that are incompatible with it, Unix becomes incredibly tiny. So Cloud ABI only has 58 system calls right now. There might still even be some redundancy in there, so you could trim it down even further. This is pretty tiny because if you sort of compare it to FreeBSD, I think FreeBSD has something like 430 system calls by now. And say if you want to sort of add support for running FreeBSD binaries to another operating system, implementing 430 system calls correctly is quite a challenge. So by only having 58 system calls, it is pretty easy to add support to different operating systems. And that's what I've been doing over the last half a year. I managed to integrate support for Cloud ABI into FreeBSD, so the latest version of FreeBSD can just run Cloud ABI binaries out of the box. And I also happen to have a patch set for OpenBSD that's almost entirely complete. There's some tiny things missing, I think, like which was the one, POSIX fadvise, where you can sort of advise the I/O pattern that you're going to perform on the file. Just these really tiny things that are missing, simply because NetBSD itself doesn't support this. But in general, the port is pretty much complete, and it works really well. I also have an experimental Linux port, but that's a bit harder because for the polling framework, I'm sticking to KQ, and Linux doesn't really support KQ. So this will take a bit longer to get working, but it is, in fact, possible to sort of compile an application once and run it on all these operating systems consistently. So now that I've explained what Cloud ABI is, let me sort of explain how you can develop software for Cloud ABI. So Cloud ABI is a cross-compilation target. So instead of just using your standard C compiler that's in your system, you just need to use a cross-compiler toolchain to build software for it. In general, cross-compilation is pretty hard. If you sort of look at all of the open source packages out there, a lot of libraries don't really want to be cross-compiled for all sorts of silly reasons. So they start to sniff around for all sorts of random files outside of the paths that you provide that it is allowed to search in, or it uses certain autoconf checks that simply cannot, that don't work when you're cross-compiling, because it actually needs to execute code on the system itself to determine how the system behaves. also setting up the cross-compilation toolchain is pretty hard because there are a lot of components involved. So first of all, you need Clang, bin utils, a standard C library for Cloud ABI, a math routine fallback library, compiler RT, a C++ standard template library, a stack unwinder, all sorts of random components that are pretty hard to set up. And what's also quite annoying is that most open source projects need to be patched up in some way. So of course, removing all of those system calls like open will break software here and there. My observation is that this is more a problem in applications than in libraries. So, for example, the libpng library, I tried porting it to Cloud ABI. That one was incredibly easy to port because all of the existing code would build, except a couple of the utility functions that sort of allow you to load a file from disk directly instead of just loading it into memory first and then calling the actual underlying API to decode the image. But if you sort of remove those functions, then it typically builds pretty fine. What does cause a lot of breakage is that Cloud libc, the standard C library for Cloud,
Low battery. Okay, it works.
hello, hello. Yeah, they die out rather quickly, those microphones. Yes, but Cloud libc also tries to deprecate some of the features that were either like specific to BSD, so BSD specific extensions or System 5 specific extensions, or functions that were part of the C standard but were removed over time, you know, functions that are prone to buffer overflows, for example. So by cutting down on those functions, you actually see that some pieces of software built, but that's sort of good. It's sort of shaking the rug to actually find bugs in pieces of code, or potential bugs. Another issue that sort of makes it pretty hard to build software is that AutoConf from before March this year doesn't support Cloud ABI at all. So any library out there that uses AutoConf from before March this year, if you run /configure on it, it will simply print, sorry, this is Cloud ABI, I don't support this. So this is the reason why I started working on something called the Cloud ABI ports collection, of course, sort of a logical continuation. And the idea behind it is that it's a ports collection that cross-compiles software and turns it into native packages for your operating system. So right now what I do is I build all of the libraries once, and I automatically generate packages for FreeBSD, DragonflyBSD, NetBSD, OpenBSD, Debian/Ubuntu. In the nearby future I also want to provide RPMs, but the file format for that is just completely horrible, so that's the reason why that still hasn't happened yet. But all of the files installed by all of these packages are just identical. So it doesn't matter whether you're on OpenBSD or DragonflyBSD, the packages contain exactly the same files. Well, there's one exception though. Some of the files, they sort of need to hard-code absolute path names, for example, lib2 archives, and those are sort of custom tailored to the specific operating system they're installed on. Because depending on the operating system, the files are installed in a different directory. So, for example, in FreeBSD, all of the files are always installed in /usr/local /x8664 unknown Cloud ABI, which is the official GNU target triple for the specific architecture. So none of these packages actually contain native binaries. I'm not providing any pre-built packages for Clang or for bin utils, and the reason for this, I have the feeling that the ports trees, like for those operating systems, can do a better job at providing packages for those pieces of software than I can. You know, I have the infrastructure for actually cross-compiling pieces of software reliably, but performing native builds for a variety of operating systems just requires too much work. So there are already a couple of sort of useful packages in there. I think right now I have approximately 50 or 60 packages in there, and sort of the most high-profile ones are LibreSSL. I thought I'd mention it because I'm here at the BSD conference. And I also managed to get Boost to work, a couple of weeks ago, which is actually quite an accomplishment because you can build a lot of nice, well, fat C++ binaries with Boost, but it does contain a lot of sort of a nice bag of tricks. So here I sort of try to explain how you can use Cloud ABI ports. It's rather easy. So the first step at the top, this installs the Cloud ABI toolchain package, and this package is not part of the of the Cloud ABI ports tree. It's just part of the regular FreeBSD ports tree. And it installs a copy of Clang and bin utils. As soon as you install those packages, you still can't compile anything sane. There are no header files installed on the system, no libraries. It doesn't make any sense. So what you can then do is you can just add a couple of lines to your etc pkg directory, a couple of files, cloudabi.conf for cloudabi.key, that explain where it can find the binary packages for Cloud ABI. And after you add those files, you can run pkg update to actually fetch the package index. I'm not showing the exact procedure or like the contents of those files because it also involves like typing over a huge PEM file for the package signing. So that's the reason why the instructions are just really brief here. So after you update your package index, you can just install a package called x86-64 unknown Cloud ABI cxx runtime. And this package name is unfortunately a bit long, but it's sort of the best I can do because what you see over here is simply the target triple, and this is the actual name of the package. So it's sort of a consistent naming scheme. The advantage of this is if the Cloud ABI ports tree would sort of add support for multiple architectures, the naming scheme wouldn't clash. It should always be possible to install a cross-compiler for a random architecture on any platform you want. That's the idea.
This assumes that package is available. Does it also work
This example was like specific to FreeBSD because I'm a FreeBSD fan. But if you're using NetBSD, then as far as I know, they don't have like a global configuration file, but you would just say package add, and then providing it a long URL or something like that, or setting some kind of environment variable.
There's some configuration files.
Oh, yeah, oh okay, yeah, then I...
Installed by default would be empty.
Yeah, oh, that's good to know. Well, then I should update my documentation to sort of explain how to use that. But yeah, there are NetBSD packages as well, and they use a different procedure, obviously. So now I'm going to explain how you can start Cloud ABI processes. So this is a very simple re-implementation of a Unix tool called ls. And what it does, it expects a directory in standard in, and a TTY or a log file or whatever in standard out, and it just prints the entries in the directory. So running this is actually pretty easy. What you do is you just compile the executable with the Cloud ABI compiler. You then load up the kernel module on FreeBSD at least to be able to run Cloud ABI applications, and then you can just run it. So /ls, we need to provide it a directory, so we just provide the directory in standard in. Looks kind of weird, but it works. So we saw that this works for ls, but still it doesn't really scale up that well. So first of all, the shell can't really create network sockets if you like. So spawning a web server like this from the shell doesn't really work. Another problem is, assume you have a program that needs a lot of file descriptors in startup. How are you going to tackle that problem? Say it's a web server that listens on 5 network sockets, requires 17 root directories, and connects to 8 different database backends. It becomes really hard to start those applications properly. There's a really high probability that you just mix up all these file descriptors and that it's, I don't know, it writes garbage to log files and it accidentally overwrites other files on disk. There's like a huge danger of simply starting it from the shell directly. So there needs to be something better. So what I wrote is a pretty simple tool called Cloud ABI Run. And what it does, you just provided the executable and a configuration file, and it starts up the executable with the configuration file that you provide. And this tool sort of merges the concept of configuring the application in general, so having a config file for your application, and injecting resources into it. And I'll sort of show you how that works. So say you would want to write a very simple web server that has like a configuration file that looks like this. You know, you just can provide a host name for example, error messages or log messages. You provide the number of concurrent connections. If it spawns a thread pool internally, might spawn 64 threads internally. You provided a list of IP addresses on which it should listen, and like a log file in the root directory. With Cloud ABI Run, you sort of annotate this file in a certain way. Namely, you add special tags in a special YAML namespace. So instead of saying like, listen on this IP address directly, you say, listen on this socket that is bound to this address. The same goes for the log file and the root directory. You say !file and then the path name to the log file. There are a couple of other attributes you can add to this, like how the file should be opened, which mode, which writes, etc. But I've sort of removed them from this example to sort of make it a bit more clear. And what happens then is that Cloud ABI sort of pre-processes this file. So it opens all those path names that you've provided. It creates all the sockets that you list in the configuration file, and it just replaces them by the file descriptor numbers. So you just end up with this configuration internally. And what happens is that this configuration is passed on to the program. So programs no longer use the traditional int main, int argc, char argv function. They use another function called program main. You can still use int main, but in addition to that you can use program main if you like. And this function doesn't receive like the traditional string arguments that you normally have in C. It sort of it gets called with like an opaque handle to like the root of your YAML tree. And then there's like a really tiny API, arcdata, get, etc. And you can call those functions on those objects to extract the values. So you can, for example, iterate over a map and walk through all the key value pairs that are inside of it. You can walk through arrays, and you can extract the values of primitive types like booleans, integers, and strings. So file descriptors are also like a primitive type to this tree. They're not integers, they're really like an opaque file descriptor object. So what's nice about using Cloud ABI Run, it brings back the paradigm of having like a single configuration file in which you can configure your entire application. This is normally destroyed if you sort of have the escapability-based environment in which you have a separate set of file descriptors, but Cloud ABI Run merges this together again. As I said, it sort of makes it impossible to invoke the process with the wrong order of file descriptors, because there is simply no order of file descriptors. They're really just nodes in a YAML tree. It also makes sure that it doesn't leak any unnecessary file descriptors into the process. So what happens is that only the file descriptors listed in this configuration are provided to the application, and they're also numbered sequentially starting at 0. So there's really a deterministic way of starting processes. If you start a process with a configuration file, it always uses the same ordering of file descriptors. There's a question. The question is, can I handle environment variables? And the answer is no. This is actually a replacement for command line arguments and environment variables at the same time. Yeah. And also for software developers, this is nice because you no longer. Oh, there's another question in the back.
How do we handle consistency between the configuration file and what the program is actually expecting? Like if you forget a line in the configuration file, then that mess up things just as well.
So the question is, how do I handle consistency between what's in the configuration file and the process? If you would forget a file entry and the process would still expect it, how does that work? So right now, the advantage of these tools already is that then your application wouldn't use a random file descriptor that happens to be open and accidentally read from it or write to it, which is already an improvement. But the underlying problem you're sort of raising is, isn't there like a way you can enforce a schema on this configuration? Sort of. So eventually it would be nice if there's a way like where there is a separate schema language where you explain sort of what schema it needs to have, and that it automatically sort of creates a parser so that you sort of have inside of your program main function, you just say like parse the entire argument data structure according to the schema, and you get native structures in C or C++ back.
Pass down the YAML file to this program as well?
Yes.
Okay.
Yeah, so the reason why I'm using YAML for this and not, say, a protobuf would also be a really nice solution for this, is that I still sort of want to keep the ability to just get an easy textual representation of what was passed down to the program for debugging purposes, for example. You know, with a binary protobuf, it's really hard to extract the original schema. So that's why I thought that YAML is a good match in this specific case. So now that I've explained sort of how you can start Cloud ABI processes, I briefly want to talk about the use cases because, well, there's still enough time. Yeah, so one of the cases where I think that sort of Cloud ABI sort of rocks is if you develop hardware appliances. Hardware appliances are typically just, you know, a system running FreeBSD or Linux or whatever, and they just run a set of programs that were developed by the specific vendor of the appliance, and it sort of, they always sort of run in this fixed topology, you know, like a mail server that, you know, needs to talk to a specific spam filtering daemon, or a web server that needs to talk to a specific database backend that's running on the system, like a real fixed topology. These individual processes, they could just be hardened piece by piece, and that would like improve the security of the product significantly. So I worked for a company back in 2007, I think, a real long time ago, and they used a commercial spam filter in their email appliance. So they developed the actual appliance, but they used a binary blob for the actual spam filtering. What if you could just somehow force that spam filter, force the authors of that spam filter to provide a Cloud ABI binary that really only accepts email on a single socket or something, and then sends a reply back whether it's spam or whether it's spam or not. Sorry. That would make the application a lot more, or your appliance a lot more secure. Also for network appliances, we see in FreeBSD that we have support for NetMap nowadays, and that allows you to really efficiently extract network queues and pass them back to user space. What if you could just have a user space firewall process that's like strongly firewalled, strongly sandboxed? You don't want that a single like buffer overflow in this user space firewall causes a privilege escalation. You know, really sandboxing that is a really good idea, and Sandbox is, Cloud ABI is a really good tool for that, in my opinion. So another use case I thought about is sort of having Cloud ABI as a service, where customers can get like cloud computing resources, not in the form of virtual machines that run Linux or FreeBSD, but the only thing they need to do is provide a binary that only talks over a couple of channels, a couple of fixed channels, and can only do the things that they require. This cuts down on a lot of systems administration overhead. I've been using App Engine a lot at my previous employer, and it's really nice. You just write a pile of Python code and you just throw it over the fence, and Google just runs it on their infrastructure. That's what cloud computing needs to be. It shouldn't be the case that you just get a couple of virtual machines in the cloud. That shouldn't be all of it. You know, the existing cloud computing infrastructures, they make it easier to get your hands on hardware, but the maintenance aspect is still as large as it used to be, and having sort of a cloud computing provider that does all of that stuff for you, and you can just run your tiny programs that you're interested in, that would really cut down on maintenance. So another thing I've been thinking about sort of in that area is, say you have some kind of computing cluster, so your own private cloud, so to say. What you can do is you can come up with a cluster management system that can make some really smart scheduling decisions if it would sort of run Cloud ABI processes exclusively. Because all of the communication between processes is known up front, a cluster management system can now make some really high-level decisions about, you know, I have a database server running on this side of the data center, and I'm about to start up a web server on the other side of the data center. Is that really the smartest thing to do? Wouldn't it make more sense to run it in the same rack? Those are things that sort of are provided automatically if programs use like a dependency injection-like scheme exclusively. So these are also things that I sort of, once I sort of stop working on Cloud ABI itself, you know, want to investigate whether it's possible to come up with a cluster management system like this. And these are the kind of use cases I'm sort of investigating or pondering about, and maybe you guys can think of other things that Cloud ABI would be nice for, and if you have such an idea, let me know. I mean, it's always really nice to hear what people sort of have in mind with technology like this. So Cloud ABI is just open source. It's almost all of it is licensed under a 2-clause BSD license, as far as I know. The C library, you can find it on GitHub. The C library also contains all of the system call definitions and all that kind of stuff. So if you want to add Cloud ABI support to your operating system, that's where you actually get the binary interface definitions from. The ports tree is also on GitHub, of course, but in generally there's no need to check it out because the pre-built binary packages are typically the things you want to install, but the instructions on how to obtain those binary packages can also be found on that page. There's an IRC channel if you're interested in sort of joining the club. And if you think that Cloud ABI is a nice product and you actually have some sort of commercial interest in using it, my company, Nuxi, is very happy to sort of offer commercial support on this or give trainings. And that'll be it. Are there any questions?
As far as I understood it, you can run the same executable in Debian, Linux, and FreeBSD. Is this true?
So the question is, can you run exactly the same executable in Debian, NetBSD, FreeBSD, etc.? And the answer to that is yes. So
Second question.
the second question.
Is there a performance penalty for this?
So the question is whether there's a performance penalty for this. And the answer for this is no. So at least on the BSD kernels, it's the case that there's support for running multiple binary interfaces. So you could even say that the fact that we can run FreeBSD binaries on FreeBSD is because the FreeBSD kernel has an emulation layer for running FreeBSD binaries, so to speak. And what I've done is I've just added an additional emulation layer that has its own system call table and its own system calls, but those system calls are like really thin wrappers around the internal kernel APIs. They're almost identical to the standard FreeBSD implementation. So I haven't measured this explicitly, but I have no reason to believe that this is any slower than like a native FreeBSD executable. On Linux, however, there is a tiny performance overhead, and the reason for this is what they have is they have like a really fast system call path that's enabled when you're not tracing a process, you don't have any debugging options enabled. But as soon as you do something interesting, so for example, emulating a different binary interface or doing any tracing, then it goes through a really slow code path. Well, not really slow, but slower than the fast path. So Cloud ABI on Linux is a bit slower than running a Linux native binary, but this really doesn't apply to the BSDs at all. Did that answer your question?
Yes.
Okay. Are there any other questions? Yes, there's a question over there.
Are there any like higher level languages that I can write in that utilize Cloud ABI?
That's a really good question. So the question was, is there any support for any higher level languages? So for example, can you run a Python interpreter on Cloud ABI? The answer is not yet. It's really something it would be really awesome if I get that working. I'm really hoping that I either have time to work on this or someone becomes really interested in using Cloud ABI and starts to work on this. It would be really cool to have, but it's not there right now. Like running Python and running Java, those are sort of the top two runtimes that I want to have.
Is there any support already implemented for load balancing, dynamically starting processes?
So the question is there any support for load balancing or starting processes on demand? And the answer for that is no. Right now I'm really busy with like actually being able to run these processes and porting software to it. But the actual tooling around it for managing Cloud ABI processes is, apart from like the Cloud ABI run tool, sort of non-existent. Yeah. Any other questions? No? Then, well, I think this is it. So I'll still be at the conference for the rest of the day. If you have any questions, just let me know. And don't forget to go to the PGP key signing party in the Red Room during the lunch break.
Of course, our usual present.
Mm-hmm.
You.
Thanks.
Thank you.
It needs to go in here, right?
Like this.
Nothing works.
It's just like
I don't have one of these here, so that's it.
Does it work? Does it work?
It works.
Wonderful.
Don't flee. The right one.
Yeah.
Okay, good afternoon. Let me introduce to you François Tigeot from the Dragonfly team.
Yeah. Hello, everyone. Yeah, thank you. So I will be speaking about the state of the Dragonfly graphics stack. And hopefully we should get some signal. Yeah. I'm François Tigeot. I'm a system engineer at a company called Synthesio. We're doing social media business intelligence. Developing graphic drivers and related things is not my main job. I have been an Xorg and BSD user for a long time. Recently, well, relatively recently, I've also become a Dragonfly developer. One of the things which was beginning to piss me off in 2012 was the state of the graphic drivers. So I've started to port DRAM, i915 and Radeon drivers, and I have been updating the i915 drivers since then. Well, Dragonfly is probably the less well-known BSD operating system out there. It was forked from FreeBSD in 2003, so 12 years ago now. It's a Unix-like operating system, of course. It's even a Unix descendant, a BSD descendant. One of the most important things in Dragonfly are multiprocessor performance and scalability. So for that, Dragonfly uses per-core replicated resources. It's just not trying to lock everything like if hardware was still running on SMP machines. And since some variables and resources are duplicated, many operations are naturally lockless. Dragonfly also has an innovative Hammer file system, which retains history. The file system can be considered a database in some sort of way. It retains all operations, all transactions, for a 24-hour period. And it is also able to replicate these transactions to slave file systems. So we can use two disks in the same machine. If the main disk breaks down for some reason or another, we can use a copy of the data on the second disk, and we can also do that in real time with remote machines. So it's great for disaster recovery. The file system has also interesting features with regard to deduplication. It's able to deduplicate data without using a huge amount of resources. So you can deduplicate data with a 4 GB machine. It's quite cheap with regard to hardware resources. You don't have any limit on the amount of data you can store and process in that way. And the third most interesting feature with the file system is the use of SSD as a second level file cache, what we call swap cache. It's a mechanism which uses the existing swap mechanisms. Basically, we can almost indefinitely extend the file cache by putting file data into the swap area, and preferably on an SSD. So Dragonfly is really great for file servers. Going back to the graphics stack, the graphics stack is now divided into various parts. There are various layers of drivers. We have kernel drivers and all sorts of user drivers. In the old times, Xorg was its own operating system. It was trying to enumerate PCI resources, trying to manage memory, DMA engines, and so on. So, well, it didn't really make sense, and since most users of Xorg these days are Linux people, they have started to put some parts of this huge stack into kernel drivers, which is quite logical if you think about it. Memory management, PCI enumeration, it's the job of the operating system. So we now have a problem in BSD systems with these kernel drivers, since they're written first and foremost for Linux. And so I decided to use the Linux kernel drivers. Companies like Intel or AMD have tens of engineers just working on the kernel drivers for their particular GPUs. I think the Intel team has maybe 20 to 50 people alone working on the Intel kernel GPU drivers and other drivers in the USLN stack. So since nobody has heard of Dragonfly, nobody is writing Dragonfly drivers. I'm also a lazy person. Well, I'm working as a sysadmin, so I like to do as few work as possible. So in a way, I'm not porting the Linux drivers to run Dragonfly, but I'm porting the Dragonfly drivers, the Dragonfly kernel to behave like Linux. And the idea is to use the Linux drivers as unmodified as possible. So from the point of view of the graphic drivers, the kernel is Linux. Of course, it's not completely true. So we're using a compatibility layer for that. Many header files in a subdirectory of this DRM. I didn't even have to write most of them. There were already many existing wrappers in other BSD projects. So I took most of them from the OFED project in FreeBSD, which is mostly about InfiniBand drivers. I also took some files or some application interfaces, little bits here and there from OpenBSD and NetBSD. And we also implemented some APIs locally, like IDR. It's probably the most famous one. It's about small integer management in the Linux kernel. And then, of course, I had to implement some things myself. So we have many files in a subdirectory of the DRM subsystem. They're using the same file names as in Linux. in order to use the Linux drivers as unmodified as possible. Linux itself is a clone of Unix, so we already have most of the required things. They are just not implemented with the same function names and so on, so most of the things are just wrappers. We have almost 80 include files now, and we're approaching the 9,000 lines of code limit. Yeah, we also have some C files in order to implement some relatively complex functions. All of that is under BSD 2 license. So my most important area of work is the i915 driver. It's a driver for Intel GPUs in the kernel. So right now in Dragonfly we're mostly synchronized with Linux 3.17, except for small hairy parts like MST. MST means multi-stream transport, and it's a way to manage screens with huge amounts of pixels, like some 4K displays. Some of the 4K displays are not one screen, like you would think they would be. They are basically two screens stick together. And so if you try to manage it with regular drivers, regular software tools we had until now, the computer sees two different screens. So it's a bit hairy, and we are not completely managing that part yet, but we'll eventually get there. For the Intel GPUs, we use Linux 3.17 code. And we also have some critical patches for more recent Linux versions. In some circumstances, you can have hard crashes, or you can lose display timings and so on. So we're being proactive in finding known bugs and backporting them. The GPUs supported are almost everything. Well, everything you can still find on a working PC right now. Since Dragonfly doesn't support 32-bit CPUs anymore, we don't care about hardware which existed before Pentium 4. So basically the Intel GPUs you can get working on Dragonfly are the ones who came with Core 2 hardware up till almost the last generation, the Broadwell ones. The very latest generation is called Skylake and is beginning to appear this fall. So we support most of the hardware there right now. For Skylake, we will have to update the kernel drivers to at least Linux 3.19. That's the first Linux version which started to include Skylake support. But according to some Intel people, we will probably have to upgrade until Linux 4.3 in order to get rock-solid support. So I've been doing most of the work on i915. I did the initial porting from FreeBSD 3 years ago. Other people have become involved with time. Johannes Softman found some critical bugs and improved some parts of the driver. Matthew Dillon, Imre Vesdas, and Rimvedas Jasinskas were all involved in fixing bugs. Some very critical, like the virtual memory subsystem. She's very hairy with modern GPUs. If we go back to history, we first started to get interested in DRM KMS support in 2010. There was a Google Summer of Code project. A student was supposed to implement DRM KMS support for Intel GPUs. It did some huge amount of work, but sadly I was never able to make the code work on my machines. So, well, I suspect it probably only worked on this hardware. So in 2012, I found out FreeBSD had ported the i915 driver from Linux. So I started a port from FreeBSD. It made sense at the time, since the Dragonfly and FreeBSD drivers are not kernels are not too different. Well, Dragonfly was FreeBSD, so there's a huge amount of shared storage, shared data structures and functions and so on. So it was a relatively straightforward decision. But then 1 year later, I also discovered the FreeBSD developer working on i915 support stopped updating his work. So in September 2013, I started to try to synchronize the driver with Linux, since FreeBSD didn't do any work on it anymore. Before that, we had to do a huge amount of work to make the drivers, well, start working. We had in particular implemented something called PAT, Page Attribute Table, in the kernel. It's a way of managing cache memory on a per page basis. A page is a small amount of memory, like 4 contiguous kilobytes on Intel hardware, well, Intel and AMD hardware. So it was a huge amount of work, very difficult. For 1 year, we didn't really have something working. The code was building. You could load the kernel driver, but then you only got garbage on the screen. So, and it turns out modern GPUs are not what we call memory coherent. Right now, if you run a program made for MS-DOS, for example, on a modern PC, it works. Well, most of the time. The hardware is compatible, but for kernel drivers, it's much more difficult than that. GPUs don't see memory in the same way as the CPU cores do. If you write a value in a variable, it's not written to memory. It's written to a cache buffer somewhere in the CPU die. First level cache, then eventually it will migrate to the second level cache, the third one, and eventually it will be returned into the main memory. But GPUs, even the ones integrated into CPU dies, don't see the whole cache hierarchy. If the value you just wrote in a variable is cached, the GPU engine never sees it. So you can have all sorts of funny memory corruption. The GPU may be expecting some particular commands and never sees them, or only see half of them. It gets pretty hilarious pretty quickly. So we have to make sure some memory ranges are never cached. That's probably one of the most difficult things to do in a modern kernel. So once we make sure we probably disable cache support on some small memory ranges, we started to get Intel hardware working. We were first able to display small things like X-terms and then more complex animations and, well, the PC is starting to fall together. So then I did a huge amount of bug fixing and trying to synchronize things with Linux. It took me almost a year before being able to have something close to Linux 3.8. We had huge problems with the original FreeBSD codebase. It was never based on a particular Linux version. it was a mix of various things. So it was very difficult to synchronize it with Linux. But then, after almost a year, I finally had something close to Linux 3.8, and I was able to get Haswell hardware working. Haswell is the GPU generation which Intel released in 2013. Right now, they have started to release the next generation, the next two generations, Broadwell at the beginning of this year, and Skylake is appearing right now. And so in May, I was also able to update the kernel driver enough to get Broadwell support. So to be able to support, for example, laptops from 2015. The GRM Radeon kernel driver is also interesting. It's also mostly synchronized with Linux 3.17. It also uses a special memory manager called TTM. That one is also very hairy, very difficult to work with. In general, everything related to virtual memory management is very difficult to use and interact with. So the TTM memory manager is only synchronized with Linux 3.11, but well, it works well enough for now, so we're keeping it at that level. Many people were involved. I did the initial porting, and then other people took over. For Michael Neumann was a guy from Germany, updated the driver up to Linux 3.11, and then Remidas Jasinkas took over and updated it to the present level of Linux 3.17. Other people were also involved in critical fixes. We had Imre Vazdas and Matthew Dillon, who did many things to improve the stability of the driver. Yeah, for also almost 1 year, we had a compiling and almost working driver, but stability was not there. We could probably run the machines from 1 hour at most before we were starting to get crashes. So it took a long time to stabilize things again. The history is pretty straightforward. 1 year after being involved with the initial i915 porting, I started to port the Radeon driver and its memory manager. I also used Linux 3.8 as a target. 3.8 made sense since it was relatively close to whatever was in the FreeBSD code base. Well, the Radeon driver itself was synchronized with Linux 3.8 in FreeBSD, so it was a no-brainer. In October, so a few months later, the drivers were compiling and loading, but it took us almost 1 year until summer 2014 to get them stable enough to be used for regular work. In February of this year, other people, so the guys as I mentioned previously, Remidas Jasinkas, Michael Neumann, wanted to upgrade the driver, so they managed to update it to Linux 3.9 and then 3.11 and then 3.17. So it was relatively straightforward. There are not as many changes between Linux versions in the Radeon driver than we see in the Intel driver. DRAM i915 changes can be huge between two Linux kernel versions. We can have as many as 50,000 line of codes of differences between two Linux versions. Speaking about Radeon hardware, we will also have to start working on a new driver called AMD GPU at some point. Basically, the AMD guys are thinking the existing Radeon driver is too complex for its own good, and they're trying to implement support for newer hardware in a brand new driver. So it's relatively new. It only was committed to Linux in 4.2. But we will need it for some recent GPU families like Topaz, Tonga, Carrizo. Well, it's hard to say which GPU models correspond to these code names. But well, it's marketing and all that. So, but we will need it someday. Now, I also have to speak about NVIDIA hardware a bit. NVIDIA hardware world requires the Nouveau driver to be supported. It was never really well supported in Dragonfly. At most, we had a 2D only accelerated driver called XF86 Video NV. But it's hard to know what the NVIDIA guys are thinking. They had a limited driver. They stopped updating it years ago, so NVIDIA support has been regressing since then. It's the same situation on Linux. They don't have any Linux driver either. If you want to have accelerated support on Linux, you have to use proprietary binaries, which are not supported by the kernel people, and well, there are all sorts of problems with that. So in the Dragonfly community, NVIDIA hardware support has been regressing for years. So of course, almost nobody bought NVIDIA cards. Almost nobody has any investment to protect. So quite logically, almost nobody is interested in this driver. The DRM Nouveau driver is a completely reverse engineered one made by some Linux enthusiasts. They did a huge amount of work. It's really amazing what they were able to do. But, well, since almost nobody has the hardware, interest is low, and, well, I still played a bit with it, tried to get it to compile, and then I noticed some files in different subdirectories have the same name, and that's a no-go with the existing BSD build system. So, well, I just gave up at that point. So it will probably become important at some point, but we're first trying to get the Intel and Radeon drivers working properly first, and then getting DRM Nouveau working is a very low priority for us. As far as I know, only one BSD project has been able to implement DRM Nouveau support, and that's NetBSD, with someone with it in this room. Yeah. Basically, Taylor Campbell did the work. I'm not sure right now if NVIDIA hardware is properly supported on BSD, but at least there's a driver. And now, quite logically, I also have to speak about the VESA driver. It's a basic frame buffer display thing. VESA is the least common denominator we can have on x86 hardware. PC BIOSes have just enough functions in their firmware to be able to export a basic frame buffer to userland. So that's what we get, a huge frame buffer. We can draw lines, pixels, and so on using the CPU. It's very slow. There is no 2D acceleration. There is no 3D acceleration. It's quite fine if all you do is display blocks like Xterms and eventually web browsers. But well, you can't use it to play videos and games with it. It's too slow for that. It's also the only way to use NVIDIA hardware on Dragonfly. The kernel drivers I just spoke about are implemented in a more general kernel subsystem called DRM, which is short for Direct Rendering Manager, directly putting things on screen and directly managing the GPU. Well, some parts are synchronized with Linux 3.17, other parts are in bad shape. We have some really old files. These parts most critically missing are DR master support, which is something which can be useful to run different Xorg servers at the same time. And we also don't have something called DMA buff, which is used to switch memory buffers from one GPU engine to another. On some hardware, you can have more than one GPU connected to the same video output, for example, the VGA port. And typically, you have laptops with NVIDIA hardware and Intel GPUs. Well, since Intel GPUs are now integrated into the CPU, they of course will be present. But some people want more powerful hardware to display 3D things and so on. So they also have NVIDIA chips on the main boards. And both of these GPUs are connected to the same video ports. And if you want to use the most powerful engine, typically you have a piece of software which powers on the NVIDIA chip and uses it to draw things in a memory buffer. And then this buffer is sent to the Intel GPU in order to be able to use the Intel display engine and put things on the screen. So this part is quite array. It involves virtual memory, DMA management, and so on. So we don't have support for that yet. So we don't have support for hybrid hardware with two GPUs. Well, two GPUs connected to the same outputs. Of course, you can use Dragonfly with more than one GPU at the same time if you have different screens connected to each GPU. Now I will be talking a bit about user-owned software. Dragonfly uses what we call dports packages. They are created from FreeBSD ports, an adaptation layer, and they run through automatic tests and validation. So the dports repository is a repository of package building instructions made from FreeBSD packages, but every package build instructions committed into the Dragonfly dports Git directory has been verified to compile and install correctly first, using Poudriere, which Baptiste just spoke about in a different session. So we have more than 23,000 packages, and all of that is automated. There's not enough manpower to maintain a complete post tree by yourselves. So it's almost the entirety of the work is done by only one guy called John Marino. So he was able to take the FreeBSD port 3 and automate things as much as possible and get things working. So for that reason, we also use the same user-owned software as FreeBSD most of the time. We have some important exceptions. So for that, we use the same Xorg server in FreeBSD, which is 1.14.7. The last released Xorg server version works fine, but hasn't been packaged yet. The various userland drivers are used by Xorg to draw things on the screen, accelerate video, and so on. These drivers themselves use the kernel drivers. They are relatively recent, but not the most recent version, since once again we're using FreeBSD ports as a basis. The important exception here is the Intel driver. We're using the last released version of the Intel driver, which in itself is a bit old, but it's better than what's in FreeBSD. I was also able to verify the very latest Intel version work fine, but since they're not packaged, we don't use them by default yet. We also have relatively recent versions of Cairo. Misa is the 3D management library for OpenGL. We're using an old version, that's the one, once again, which is in FreeBSD. Mesa 11 is the latest release. It's better. It's working better with newer hardware, such as well, Broadwell, and so on. But well, since it's not packaged yet, we just use the existing ports, the existing package. And our biggest problem right now with userland is that the FreeBSD ports are a bit stale. They're still using a very, very old version of the Intel 2D driver. So that's why I had to create a locally managed port for that driver. And I hope we won't have to do the same thing for other parts, or it could become a huge burden. Concretely speaking, if you look at what we can put on the screen, with Dragonfly, we have basic two-dimensional operations working perfectly. 3D OpenGL is also accelerated and works fine. We can play accelerated video. I was able to play 4K videos on Ivory Bridge hardware, which is the Intel generation of GPUs from 2012. Modern desktop environments work fine. We had people which praised us on the IRC channel since Kili worked much better on just the last version of Dragonfly than the previous one. We can also play 3D games. Open Arena is something in ports. It was a clone of Quake 3, I think, at the beginning. And we're able to put more than 200 frames per second on hardware from 2012. We also have people interested in GPU supports for scientific computations. There's a particular library called OpenCL, which is made for i9-15 hardware Intel GPUs. So it works fine. Someone was able to verify it had more than a 90% pass rate on Haswell hardware. So scientists are starting to use that. We have Wayland. Wayland is a sort of XOR replacement, which is also a sort of future technology I'm hearing about for a few years now. It's still a bit mysterious for me. Wayland isn't a new X11 version. Applications will have to be ported to be able to display things on the screen. There is already some working software. We know the existing Wayland software is working with the Intel driver. One developer is even using it as his desktop, but the Wayland stack has to be patched. In particular, the input stack is too different from the Linux one, and it had to replace Linux-specific code by something more portable, lib-event2 based, but apparently things work fine. We have had plenty of changes related to graphics support in Dragonfly this last year. Previously we had working kernel drivers and working Xorg support, but we didn't have working console virtual terminals anymore once Xorg was using the KMS drivers. Since the old console code was expecting VGA hardware to be present, and that was no longer the case once the DRM drivers used the hardware to their full capabilities. So some people had to rewrite the TTY layer to be able to use it as a dumb frame buffer. So we now have a console using big non-anti-aliased characters by default. It's quite readable, even on small screens. It's not UTF-8 hardware. We can only use ASCII characters, but well, it's better than what we had previously, which was a black screen or a frozen Xorg image. Still, there weren't many people who complained about that. It was surprising, but most people use Xorg these days, so we didn't have many complaints. Could probably try, trying to display the console thing. Well, no, the video, oh, yeah, it works. So, I have a prompt. And I can go back to Xorg. The most difficult spots we had to handle in the kernel drivers were virtual memory management, since Linux kernel works differently in that way than BSD kernels. Well, it was really hard to debug things and make sure all bugs were fixed. We probably still have some bugs here and there. There was also a big difficulty with the IIC API. IIC is a low-speed bus used to communicate with screens, typically. This VGA cable, for example, doesn't only send VGA signals to the screen, it's also a two-way communication channel in order to get things like monitor resolution, vertical refresh frequencies, and so on. That sort of things is necessary in order to be able to auto-detect display capabilities and have Xorg auto-configure everything without having to type hard to understand lines of resolutions and mode lines, if you remember how it was in Xorg in the long past. It was, well, very difficult to handle manually, and now all of these things is managed automatically by the hardware. But the software API is difficult to use, well, at least in Dragonfly and FreeBSD. The Linux I2C one is much better. The biggest problem we have is that devices are created top-down in Dragonfly, whereas in Linux things get auto-detected and the complete stack of display capabilities keeps growing bottom-up as the software detects the various capabilities. All of that thing is not instant. Some screens can take longer to answer commands than others. Some video projector hardwares probably don't handle display information at all, and so on. So that was one of the most difficult things to handle properly. We also have known problems. Things are better than they were 1 year ago, but we still have some work to do. And for example, if you take a web browser such as Firefox, we have tearing with YouTube videos on Intel hardware. And that's not a Dragonfly kernel bug, it's actually a bug in the Intel userland driver for Xorg. The last released version creates video tearing when you move the mouse, and it's fixed in Gitmaster. But unfortunately, the Intel people haven't released any new version since then. So I have started to package snapshots of the Git tree of this particular Intel driver. They will eventually end up in the Dragonfly package repository. We also have some cases of display corruption. It's probably some cache invalidation or another small thing we're not doing properly like Linux does it. And yeah, we had to disable cache, last level cache support in the 2D accelerated driver. Once again, it's probably some cache attribute we are not correctly managing in the kernel driver. And there's a great software test suite which is called Intel GPU Tools, which has hundreds and hundreds of small tests testing every sort of IOCTL or small kernel driver command, which is really great for finding issues. And we know we are leaking some internal kernel return values in some IOCTL, so we still have some work to do to behave properly like Linux in some of these functions. We also have other problems with the Radeon driver. Some newer Radeon models only expect OpenGL acceleration. They don't use the 2D accelerated driver in Xorg anymore. So we rarely have to use the last Xorg versions to be able to properly handle acceleration on these Radeon models. But the only package version is quite old. So once again, we'll probably have to override the FreeBSD port 3 and package the last Xorg server version ourselves in order to fix that problem. We also have plenty of things we will need to do apart from fixing bugs. Well, we should update the generic DRM code in order to be able to run different Xorg servers at the same time. We need to continue updating kernel drivers to support newer hardware. So Skylake is brand new this fall. We will need to support that if we want to be able to run on laptops everybody will be able to buy next year. Yeah, we should continue to use formal test suites like Intel GPU Tools and other ones to fix driver bugs. At some point we will want to run benchmarks and check if we're doing okay versus Linux and if we're not 10 times slower for some operations. And we also probably will want to implement UTF-8 terminal emulator. One of the developers is starting to work on it, so once again Imre Vadas. He calls that FBTken. It's somewhere on GitHub. It's somewhat usable now, but it will need plenty of improvements to become the default. So finally, I like to thank all the people involved. I did the initial driver porting and the i915 upgrades, but plenty of other developers became involved, just fixing bugs or adding support for some small things here and there, like brightness support, display brightness. At first, we didn't support it on Intel hardware, but now it works almost out of the box. We have some syscontrol for that. We can also use keys on some laptops, maybe this one. Not sure. Yeah, no. It only works on VG hardware apparently. Oh, wait. Yeah, no. No, it's not visible on the video projector. We will want to continue to improve things, and for that, having plenty of eyes reading the code and trying to fix whatever little things bother them is really great. So I want to thank all these people, and I'm probably forgetting others, but they were the most involved names recently I could find in the source code. So I'm done. Do you have any questions? Yeah, Taylor.
Quick note, NetBSD does not actually support Nouveau right now. I got it to build, but I did not have time to make it actually work. Although we do have a script to deal with the file name issue using this bracket.
Okay, so basically Taylor just said Nouveau is building in NetBSD, but it was not able to make it work completely. Not yet. Anything else? Yes?
What kind of troubleshooting tools you were using to find issues and like find bugs? Like what is the root cause for some graphical glitches?
Yeah, what sort of tools are we using to find bugs and fix them? Well, until very recently, we didn't use any special bug, any special tool. Well, we noticed when things were obviously wrong, and it was relatively easy to find the root cause of some of the issues, since we were able to get kernel crash dumps. So yeah, we were using the regular tools you can get for in case of kernel panic. We had memory dumps and were able to analyze call stacks and so on. Some things still escape us, but it's relatively obvious of what they are. So display corruptions on Intel GPUs can only be memory mismanagement somewhere. Reading Intel bug reports, Linux kernel bug reports is also very, very interesting. For reusing relatively old releases of Linux as a basis. And plenty of bugs have been discovered since then and fixed. So just reading Bugzilla and backporting, or reading git logs and backporting fixes is really helpful for that. And we just very recently have started to use Intel GPU tools. That will also be very helpful in finding the small corners of our driver where things behave differently than Linux, and the kernel sends bogus data to userland drivers. Yeah. Yeah, George?
As far as having a newer version of Xor, you mentioned that you may having a newer package version. Do you plan on doing that, or are you going to wait for the
as far as having a newer version of Xorg, we're planning on doing that, or waiting for FreeBSD people to do it. Well, we have plenty of things to do right now. Managing an Xorg port by ourselves would add some work to our already to big list. So we're trying to avoid that if we can. It's a bit of a shame since I know some FreeBSD people have already packaged Xorg 1.17. It's just not in the official repository. Well, there was probably some problem on some old FreeBSD version which prevented it from being included, but I will need to talk to the involved FreeBSD people and see if it can be upgraded quickly. But yeah, if we will have to wait for months or years, no, we'll just override the port and do it ourselves. Yeah.
How do you manage the source code being ported from Linux versions that you have in the beginning, like a bunch of different mixes of different levels of code? So do you like comment each line that this is from 3.8.14 and this is from 4.2?
How do we manage the import of code from Linux to Dragonfly and the differences? Well, we don't keep trace of the origin of particular lines of code. What I'm making sure of is trying to get things as close to Linux as possible. Ideally, we wouldn't have any differences between the Linux drivers and the Dragonfly drivers. Right now, since the code is relatively well synchronized, I'm able to replay Git commits in the Linux kernel and apply them to Dragonfly. So that's probably the easiest way to do things. Well, in my way, it's very important for testing and be able to make sure everything still works perfectly. For changes between Linux versions can be huge. And if I was trying to port a 10,000 line of code difference commit every time, well, I'm pretty sure I will have to spend the next 6 months debugging it. So what I'm doing is importing Git commits, applying them on Dragonfly as patches, making sure everything still works as it did previously. Eventually fix bugs if some are discovered. But by keeping things in relatively small steps, I'm able to avoid a huge amount of pain. Basically that's it. Git commit, git patch, diff, and so on. After a while, I consolidate all these replayed Linux commits to one giant commit, well, just by using git rebase. That's it. I'm able to produce a huge git patch. For example, moving between Linux 3.11 to 3.12 and apply it to the Dragonfly tree. And if we then discover bugs on some particular hardware, we can tell the end user to use the non-rebased version in a different Git branch and pinpoint the commit where things started to get wrong. And then we only have 10 or 20 lines of code of differences, and we can fix things pretty quickly. You're welcome. No more questions? Yeah. Thank you. Thank you, Olivier.
All right. This one? And
Yeah. Oh yeah.
is the other one working?
Yeah, the other one. Which one should be working?
Ready for our conference, Deb?
What's that?
Our concert?
Yeah. Are we rock stars? Okay, got that. I don't think that's right.
No, the loop actually goes behind your head.
Oh, like that? Okay. What's the problem with having hair? Way too much of it.
There's always George.
No, you just moved. Oh, yeah, I know, George. Does this look right? Is there a mirror in? Thank you.
That headset doesn't make you look fat.
What happened to the mirror? You got some.
Right.
Better to look good.
I feel like there's something floating through my face.
Turn it on. I have to talk to us.
Hello, hello. Can you hear me?
I can hear you.
It's all that matters. Ooh. Okay.
Can you hear me?
I can hear you.
We're ready for our Thank you.
Okay. So we're just gonna stand together. Okay. I guess we'll get started. I'm Deb Goodkin, and I'm Executive Director of the FreeBSD Foundation. This is Ed Mast. He's the Project Development Director. And so anyway, welcome to our talk. We were actually granted a slot because we're platinum sponsors at this conference, so we want to take advantage of it. And the purpose of this talk today is to talk about what we do from the at the foundation, as well as how we support the FreeBSD project. And that is our mission. I mean, basically, our mission is to support the project and the community worldwide. I have to actually look back to see what all of this says, because we don't have it up here, right? So this is who we are, and we're based in the United States, 501c3. And we have a volunteer board of directors. We have 3 of them sitting in the front row right now. And, and at the end of this talk, too, if we have time, and we should have time, we're actually all going to come up here so we can answer questions. We have a staff consisting of myself. We have Ann Dickinson, who is our marketing director, who actually does a lot of support for the project by doing advocacy. And so even though she's our marketing director, it's not necessarily marketing for the foundation. She does a lot of marketing for the project. And if you came to our table, or if you come to our table later on, you'll see a lot of the flyers that she's helped create. Ed Mast, who's behind me, and we have other staff members around the world, like Kostik, Edward, who's here, and he's in the room here, Glenn, who most of you know, but who is a release engineer for the project. Kathy Stoltz is our administration manager and talks to a lot of you for travel grants and payments, both directions, and it does a lot of our donor stuff. We're financially stable. We're open book company, meaning that we post all of our financial information, profit loss, and balance sheet on our website. And so we try to be very transparent of what we do with the money. And so what we're going to do is we're combining this talk. Actually, I'm going to hand off most of this to Ed, and then if there's anything that I need to add, I will. But he'll take over the talk here, and I'll maybe take this off.
So this is a brief discussion about the genesis of the FreeBSD Foundation and the FreeBSD project, and this, or the FreeBSD core team. And this goes back to 2000 or so. At that time, there was a lot of upheaval and change in the project, and Jordan smirks at me. He knows this history much better than I do. It predates my involvement directly in the project, but at that time, an elected core team started out, and basically the core team is elected by the FreeBSD developers every 2 years for a 2-year term. It's nine members, and people generally serve a couple of terms, and then some will stick around for a little while, some will serve 1 term and move on, and it brings sort of some continuity to the project and also some fresh ideas into the project's leadership. And if we look at this as sort of an org chart, the core team is the top governing body of the project, and then individual teams have their own leadership and their own developers working on various aspects. So release engineering, for instance, there's a release engineering lead, a second in command release engineering deputy, and then other people working on the releases, and the same goes for the other parts of the project. And then the foundation also, the FreeBSD Foundation also started at that same time, and one possibility is you could envision the FreeBSD Foundation sort of being the top level of the project. And this is the way that I believe the NetBSD Foundation works. Basically, the NetBSD project is part of the NetBSD Foundation. But that isn't the approach that was taken when the FreeBSD project or FreeBSD Foundation started. FreeBSD Foundation is a distinct entity from the project, and so the foundation's goal is to support the project and promote the project and assist with the project, but it doesn't in any way own the project or set the direction directly of the project. And I say that although, the foundation has now staff members, grant recipients working on projects that are funded for a specific technical development or documentation or other sorts of work like that, travel grant recipients, etc. Originally, the foundation was largely a very active volunteer. The foundation board was a very active volunteer board, and so many of the foundation board members were actually doing a lot of hands-on work. But as we've grown and as budgets have allowed, staff have come on to really be able to move things forward in a way that is beyond what volunteer hours allow for. But if we look at the reality, there's actually sort of the slightly messier dotted line relationship here. So Glenn Barber is the release engineering lead right now in FreeBSD and is also a FreeBSD Foundation employee. And it turns out the reason the foundation took an interest in bringing Glenn on is because of the great work he was doing in the release engineering role, and we recognized that there was a strong need in FreeBSD to bolster that. And so, this employment relationship here exists with Glenn working for the foundation, but his responsibilities and his direction in the project is really set by the core team and his responsibilities to the FreeBSD project. And so it's his release and engineering role is not a condition of employment or anything like that. It isn't the case that the foundation employs the FreeBSD release engineer. The foundation employs Glenn, who happens to currently be the release engineer. And then if we look at the members of the FreeBSD core team and the FreeBSD Foundation, there's some overlap there as well. And then I should actually, I guess, have the core team bar kind of coming down over here as well, because I was elected for the first time to the FreeBSD core team this last election cycle. So certainly there's an overlap in the roles that various people play, but the reality is that the foundation is a distinct entity, and where people may have a conflict of interest or represent two different domains, it's just something that people keep in mind and ensure that they, to the best of their ability, don't let that bias their decision in a way that it shouldn't. And I think over time, we're going to see that overlap sort of separate a little bit in that we've been bringing on new board members onto the foundation who have complementary areas of experience, who historically the foundation board was built from people who were very, very involved in the day-to-day hands-on technical aspects of FreeBSD, and that was key in the beginning of the foundation's genesis. But over time, the foundation is needed to expand in areas and improve in ways beyond deeply technical source and doc and ports committer kind of domains. And so if you look at some of our more recent board members, it's people who can lend complementary skills to the foundation and try and set direction and goals and allow the foundation to grow in ways that it couldn't otherwise. So I'm going to talk briefly about what the foundation does with the money that's raised, and I think Deb will chime in on some of these because she has a better handle on some of these topics. Certainly, conference sponsorship is a big part of the foundation's output, and from the foundation's perspective, conferences like this are an exceedingly valuable and exceedingly important thing to spend our money on. We have some people who question the idea of putting money into conferences. Some people say everything should just go into technical development. And some people say all the money should be spent on bringing people together for conferences. It certainly is a mix of areas that we need to focus on, but conferences allow ideas to be exchanged and face-to-face discussions to happen in ways that they just wouldn't otherwise. There's only so much you can do over email or over IRC or any sorts of other communication techniques. So really getting FreeBSD developers, FreeBSD users, and others in the same place at the same time to have high bandwidth in-person discussions provides a huge amount of value. And so this is a list of some of the conferences that the foundation has sponsored this year in various ways. Obviously for Asia or for EuroBSDCon here, we're a direct financial sponsor, a significant direct financial sponsor. Other conferences, it may have been logistical support or travel grants or other sorts of things that we sponsored. All of these ones, I believe, Deb, are direct sponsorship of some sort, right?
It is. It may not be financial. It may be like a social, or not social media, but a media partnership type of thing. But we are considered sponsors for all these ones above. I was also going to include that there's other conferences that we don't have listed. For example, Usenix, Lisa, and then OSCON we went to also. And really the purpose is to get away, is to not only support the BSD conferences, but to go out to other open source type of conferences or computer conferences to actually promote FreeBSD and to recruit. And so we were at Women Encouraged last week up in Uppsala, and the whole goal was to recruit for the project. So.
Yeah, I think that's a very good point. I think historically, at least for my tenure within the project, I've seen for the FreeBSD project and conferences start out sort of fairly insular, and many of the people go to the 3 big BSD conferences every year and don't attend a lot of conferences outside of the sort of BSD echo chamber. And I think that's good and bad in some ways. The BSD conferences are exceedingly valuable, and I think all of them are wonderful conferences. But there's a lot of ideas out there, and there's a lot of conferences in areas that are important to us that we don't otherwise have a presence at. And I think that's something that over time we really want to see and support more developers, more users of FreeBSD, of the BSDs getting out to other conferences.
Yeah, and one thing that I want to point out for last week's conference was it wasn't very big. It was very targeted. It wasn't, even though it was a women in tech conference, it was, I think we had just as many men attending it as women. And but what we found was that there was a job fair that we participated in, and I thought, wow, this is going to be really weird because all the companies that were there, it was Google and Facebook and Microsoft was there and all these big companies. And but we had a lot of people come to our table, and they were looking for, a lot of the people were looking for internships and research projects. We had, it was mostly students and professors that attended. And what we found was, well, we were the only open source project, so we had no competition really. And so people, what that helped with was that people were really interested in what we offered. And so maybe they couldn't get an internship because we weren't a company, but we presented how they could work on the project and work on in areas that they were interested in, and their work would be made public. That would actually help with when they were looking for jobs, and they could put on their resume. And so we're seeing actually these opportunities that we want to go to more of these conferences. We as a foundation can't do it. We really don't have the resources, but we're trying to do it. I'm going to Grace Hopper in a week, that's like, I think, like 12,000 attendees. That's another Women in Tech conference, and that's in the States. Yeah, but we're trying to get more FreeBSD people to actually go to these conferences to represent FreeBSD and do the same thing to promote FreeBSD and to recruit to the project, because that is how we're gonna be around in 10 years and, you know, in the future, is we have to recruit to this project.
Travel grants, another area we support the project in. So not only ensuring that conferences can have the funding to be run, but also getting developers to those conferences, whether they're BSD conferences or general conferences of interest to the BSD community. So things like, for example, XDC, the Desktop Developers Conference, is something that it's very valuable for FreeBSD to have a presence at that on an ongoing basis. And when we have people who need to, people working on the FreeBSD graphics stack who need to get to that sort of event, travel grants are available if necessary to get those people there. Legal support's a large and expensive demand for a project that the foundation provides. So it's sort of more mundane things like managing the FreeBSD trademark and that sort of issue. But there's a lot of sort of hands-on direct legal support that's needed, either evaluating contracts with various companies if we're trying to negotiate an NDA, say, so that the foundation can execute a non-disclosure agreement with some sort of hardware provider while hardware is in early beta stages, and then we can manage that process with individual developers who want to work on that hardware. And so instead of having the individual developer try to negotiate with the company and having it be a long, drawn-out process, the foundation can act as that sort of intermediate role. And the foundation doesn't have the ability to sort of execute an NDA and then just make the documentation publicly available. We definitely encourage public documentation, but often early on in a new product's life, there may be errata that are under a non-disclosure agreement or something like that, and the foundation can act as a facilitator to make sure that FreeBSD is well supported early on new hardware. The FreeBSD Foundation spends a lot of money on infrastructure to support the project. So this is production server hardware for the FreeBSD.org cluster. It's systems that are in the performance test cluster in Centex, an ISP that's in Cambridge, Ontario, about 15 minutes away from where I live in Canada. So that's some high-end server hardware we use for performance testing and benchmarking and identifying bottlenecks and that sort of thing. It's that test cluster is largely focused on networking performance, but other large system and other performance investigations have been done there as well. And then also embedded boards, so various ARM or MIPS devices that we're seeing a lot more interest on in having FreeBSD run on these devices of late, and providing boards to individual developers or that sort of thing is another way the foundation supports hardware. And Deb perhaps can talk about the advocacy role of the foundation for a moment.
Okay, I have to sort of see what Ed has on the slide. I probably created this originally. So some things that we're doing, we have the FreeBSD Journal. We just celebrated having over 10,000 subscribers, and that's in less than 2 years, so we're very excited about that.
How many subscribers do we have here? Excellent.
That's good.
How many advertisers do we have here? Thank you.
Yeah, thank you. So anyway, so we have a goal of reaching 20,000 in a week next year, maybe. So we really want to grow that. And it was a great opportunity for you not only to get information about FreeBSD and features and cutting edge technology, but also if you're working on something and you want to write about it, it's an opportunity for you to get exposure. So so if you are interested in contributing, oh god, it would be George Neville Neal who you'd contact, and you can go to our website too to get contact information. We are trying to increase the diversity within the project. Right now, it's more specifically trying to get more women, to recruit more women to FreeBSD. So we're attending more women in tech conferences like I was talking about. The other thing that we're working on is separately, and I believe we have another slide, is a whole education format or curriculum for different areas, and so we want to provide a workshop, a FreeBSD workshop to women and girls. We do have the joint marketing partnerships, and that's with like USNICs and organizations like that, and that just started when we hired Ann Dickinson. Social media, we've really reached out more in the social media and promoting not only what we do, but what FreeBSD does and the other things that we see out there that's going on. And I guess we are assisting in event coordination. I'm not exactly sure what we're doing, but we do. We do developer summits, and we have one coming up in the Bay Area that George Neville Neal runs, and there's also a vendor summit too. And so in the education, that's what I was talking about, the boot camp, where we want to do like a half day or a full day. We'll have different variations of the curriculum from like non-tech people to like maybe first year CS student level, as up to maybe like a fourth year college student who's majoring in computer science or something similar to that. Right now we just kicked off our first middle school program. We're teaching it locally in Boulder, Colorado, by Justin Gibbs, and I'm helping out too. And so we're in, I believe, our fourth week, and it's definitely an experiment, and running into a few issues. But the great thing is that we'll have it ironed out and ready to provide to other people so they can teach this around the world. But this is how we're going to get kids who are, familiar with FreeBSD, because we're using BeagleBone Black platform, and we have actually people help. Ed's been helping, and Brad Davis up there, who's been helping with getting us images that work, and so eventually we'll have images on the website so people can have platforms, inexpensive platforms to use for that. Yeah. And then
we're also working on getting pre-made starter kits available from existing vendors, so that you can buy a ready-to-go pack of a pre-imaged SD card and a BeagleBone Black, and out of the box, plug it in, you follow a quick start guide, and you're up and running on FreeBSD embedded platform.
Right. So, it's probably going to take a year or two. It will take a while to get all this in place. But the last thing right now is that Robert Watson has taught, I think he's in his second class of teaching an advanced or grad level class at University of Cambridge, and George Neville Neal's been working with him, and he's bringing a longer version to the States to teach on as undergrad. So, and all these will be available on teachbsd.org, I believe, and they'll provide the curriculum. You can go there now, but there really isn't much there. But so that, this whole area is growing.
And then also, the foundation provides direct operational support to the project. And so right now, this is primarily the release engineering role through Glenn Barber, and that's because we identified that that release engineering was an area in FreeBSD that would benefit from some funded hands-on time. These other areas, system administration, Glenn also provides, is a member of the cluster admin team, and provides sysadmin for the FreeBSD project and for the foundation itself for our own resources. And then testing, QA, security are other areas that we can provide resources if necessary. And then finally, the last area of focus, and one of the largest, is direct project development funding. And so projects are funded by the foundation in a number of different ways. But the primary goal of foundation-funded projects is not to take over the FreeBSD project or set the direction by choosing projects. It really is to fill in the gaps in the FreeBSD project identified through the project's own leadership and through talking to people at conferences like this and visiting companies who use FreeBSD and all of those sorts of ways. So supplement, not supplant is the sort of my key message there. We definitely don't want to be taking on work that individuals or the individual developers or the FreeBSD using community is developing independently. We really want to be able to find those areas that aren't being worked on and step in to support them. And then also consortium development is kind of related to that. So there may be some projects, Toolchain is a good example, where it's something of interest and provides a need to many different FreeBSD users, and all of them have some interest in seeing it improved, but it's too big of a project for any individual company to take on or individual developer to take on. And so pooling those resources and getting the various people who need something there to talk to each other and form a larger project out of that is something else that we've done before. So one of the ways that that we fund projects is through individual development grants. And so this is either a FreeBSD developer comes to the foundation and says, I'd like to work on feature X, I think this is something that's needed, and I can get a sabbatical from my job or something like that. Can I obtain funding to work on this grant? And it doesn't necessarily need to be software development. It could be work on the documentation tool chain or any sort of improvement to the FreeBSD project or infrastructure. Also, university research is in the same domain. We've funded a master's student in the past, and we have one master's project currently underway. And this is sort of it allows FreeBSD to be used in areas that aren't the sort of more experimental. We're not necessarily expecting a set deliverable at the end of the master's project. Really, it is research, and it's using FreeBSD in an educational setting that may or may not produce results that are committable to the project itself, but it allows the exploration and research using FreeBSD as a base. So this is an example of a funded grant. This is John Mark Gurney's work, and this was in partnership with NetGate to improve the AES support in our open crypto framework. And this is John Mark came to us and said, that this is something that's sort of been languishing for a while, hasn't been updated in quite a while, and I have an interest in working on it. And so that's an example of that type of project. A larger consortium style project is the currently ongoing FreeBSD ARM64 port. And this is a combination of Andrew Turner, who's here at the conference, and Semi-Half, a consultant, FreeBSD development consultancy in Poland, and ARM and Cavium are involved with us on this project. And basically, Andy Turner started the FreeBSD ARM64 port as a volunteer effort maybe 2.5 years ago, something like that. And it was sort of very much a work in progress, proof of concept port. And through the foundation, we ended up bringing in sponsorship and other developers to be able to bring the port to completion in a much shorter time frame. And our goal really with this port is to have FreeBSD have ARM64 as a tier 1 platform. And so we have a Centex, in the Centex cluster, we have a dual socket Cavium ThunderX machine. It's two CPUs, 48 cores each, that FreeBSD is running on all 96 cores there, and through the effort of Sean Bruno and others in the FreeBSD community, we have ports being cross-built right now, and there's about 16,000 ports available right now for FreeBSD ARM64. So it's at the point where basically it's usable as a platform, package install, foo just works now, using the experimental repository. But this is sort of a very large-scale project that we've been able to bring multiple people together on. Multipath TCP is the university research that I mentioned earlier. And then we've got Edward in the room here and Caustic, who are our full-time development staff. And so one of the advantages of having full-time development staff as opposed to doing just project grants, which was our earlier model, is that we can take on projects that have a longer tail of integration or bug fixing or things like that, or even just take on bug fixing in general. So Caustic has been doing a lot of work on the VM system and other kinds of areas, and just having someone who's able to work on that on a continuous basis as a full-time funded effort allows for us to do work that just otherwise isn't feasible. And so the AutoFS auto mount daemon is it's an example sort of a project that, even though Edward is a full-time staff member, this is still an individual deliverable, a project that produced a single feature that's released in FreeBSD 10 now, and we can still take on those kinds of projects with full-time staff, but we can also take on projects that are a little bit more nebulous or have a longer bug fix cycle, for example. Another sort of thing that full-time staff can do that often doesn't fit well with an individual project grant model is performance analysis and performance improvement. So this is a case where we heard on some mailing lists and from some users that after an upgrade of Postgres from one version to another, FreeBSD performance was just terrible. And there was some discussion and speculation going on, but there wasn't a lot of clarity into exactly what was happening necessarily or what the path forward would be. And so Caustic spent some time doing an initial investigation, understanding what's going on, and then prototyping and testing a number of improvements to address the bottlenecks that were identified. And so it wasn't immediately clear at the beginning of this project exactly what the scope of it would be. We basically just had Caustic do the investigation, fix some of the bottlenecks that were found, and then iterate on that a little bit until we saw a expected and significantly improved performance. Secure Boot UEFI support started out initially as a project in 2012, I think, at the beginning of 2012, maybe 2013, from Benno Rice, who had some time available between switching from one job, full-time employment to another. And so he spent a little bit of time getting a prototype of the FreeBSD UEFI implementation working. And it was a proof of concept that demonstrated that the boot process works, but it wasn't something that could be committed to the tree or fully integrated. And so I took it over after that and did the final integration and cleanup, and got it into the state that it's in now, where FreeBSD 10 and FreeBSD current snapshots, generally speaking, boot and run on FreeBSD. And there's been some bug fixes on some graphics issues recently, so it generally works now on all the hardware that we found. And Edward spent some time as well fleshing out the secure boot side of the story. So the end goal of this is that the FreeBSD releases will be able to work with an out-of-the-box, off-the-shelf PC with secure boot enabled. There's still a bit more work for us to do there. VT console, the new system console, is another project that initially started out as a funded development grant, and then additional features and functionality was added after the fact. And so, for instance, I added double width character support so that we can support CJK fonts on the console after the initial work went in. Deb, would you like to discuss the fundraising?
Sure. Right now, I believe, so let's see here, what do we say up here? So we are fully funded by donations. And I believe we're at about, not including what we raised here so far, we're about 420,000 into the year with a goal of $1.25 million for the year. And it is pretty typical that we're not quite halfway yet at this point of the year. We get most of our funding at the last couple of months of the year. But we're also really trying to reach out to more corporations to who use FreeBSD to contribute, and trying to, a lot of times, like the engineering folks understand the benefits of using FreeBSD, and then it's them convincing their financial people. And so we're really trying to help provide that information to them so they can use that. And we actually have a template on our website to help. That was provided by a FreeBSD person, actually, who's one of the first FreeBSD developers, and it's a letter that he actually uses for his own company, and we get a donation from them every year. So anyway, we have a link on our website if you're interested in seeing that. And last year we did raise $2.4 million. We did get a couple one-time donations, and one was a very significant one that we have right now. We're investing, and we did use part of that for project development work for this year, and that was the $1 million donation that we received from Jan Koom at WhatsApp, which was greatly appreciated. But the other thing too is besides reaching out to corporations, we're really trying to increase the number of individuals who donate. We have a magazine that has over 10,000 subscribers, and so we really should have 10,000 donors on our donor page, which would mean a lot to this community. And I think one reason why we don't is because a lot of people think that by subscribing that they're donating to us. And one of our goals for the newsletter or for the magazine is to break even. And so when you look at your $20 subscription, a big part of that actually goes to the app service, the stores. Apple's, I can't think of the name, Amazon and Google and Apple. They take a big cut of that. And then we also have a publisher who we pay. And so when you look at the end, we don't really receive much of that. So we'd really like to encourage people who are subscribers and who aren't donors to make a donation to help. And it would mean a lot to the FreeBSD community to see that number of names on our donor site. And so please, you can help by spreading the word, by making a donation yourself, spreading the word, especially on social media, and approaching your company. And if you don't feel comfortable talking to your company, you can provide us with the contact information too, and we would be happy to approach them and ask for a donation.
Okay. And I think one of our goals in this slot was to have a bit more interactive panel discussion. That's why we have board and staff members here. So I think probably now is a good opportunity for us to open it up to discussion and questions, and sort of get feedback and see what you have to say.
So come on down.
Don't be shy.
Jordan.
We share a mic. So as I'm caught here.
I'll repeat the question for the benefit of the video.
It's not so much a question as an observation. I think that the idea of keeping sort of church and state separate is a nice one, but maybe not that meaningful in practice. And the reason I say that is, I remember from the very earliest days of the project, a lot of people kvetching about the fact that people that were employed to work on FreeBSD had, sort of a disproportionate impact because they had the time. They were able to influence the project just through sheer weight of hours and time spent passionately arguing for stuff on the mailing lists. And ultimately, there was kind of no point to the kvetching because it was just a fact of life. That you weren't going to change it. And I think as you get more into these funded projects and funded positions, you're going to be in this awkward gray zone that maybe you shouldn't avoid. It's just going to be, it is what it is.
Yeah, so just to summarize, Jordan's point is that one of the reasons for the separation of church and state, and I'm not sure which of the foundation and the project is the church and which one's the state. But one of the concerns early on was that people who work on FreeBSD as their day job have a disproportionate impact on setting the project's direction. Jordan's point is that it's not really worth worrying about or complaining about that because it's just a fact of life. And I think to some extent that is it is true. It is the case that the project's direction is set. The project happens and develops because of the people who do development, and it's the direction it takes and the pace it develops at is set by those doing the work. I think it's still important for the foundation through its funded projects to set direction and proceed in a way that that meets the needs of the FreeBSD project, that is not just what corporate donors or other individuals may demand. And I guess to some extent that that is sort of the role of the project, in that the foundation is taking on work that to meet the needs of the perceived needs of the project. Does anyone else have a feedback they'd like to offer?
I guess the attitude is that it's very easy for the foundation with its money to sort of throw its weight around. And if it is perceived as throwing its weight around, people are going to get mad and leave. And that would make us less effective. But really the point is that we as a foundation need to be extra sensitive to seeing what our role should be, which is to support the project and not to run the project. We are not the people in charge. We are the people that are trying to stand on the side and grease the wheels and make sure that things happen. But, core and the committers and the developers should be the people that figure out what's going on, and we should be as much as possible aware of what that is and working with them, and so that taking suggestions from them, etc., and being careful that we don't start being the tail that wags the dog. Right. But if the dog goes on a random walk, then we go on a random walk behind the dog.
Mm-hmm. Questions?
Comments? Large wads of cash?
That's good.
So one of the comments that, I like to ask people about, what do you do and do you get to use FreeBSD? And they, several people today were saying, well, I'd love to do FreeBSD, but I can't find any jobs where they need FreeBSD developers. And then I was talking to some other people, and they're like, well, we'd use FreeBSD, but we just can't find anybody that has any knowledge or interest in FreeBSD. So I have this notion walking away from this conference that we, as the foundation, could do something useful, which is just having a place where companies could post that they're looking for people, and people could post that they're looking for jobs using FreeBSD. And maybe in this way, some of this problem could get solved.
Dan?
I don't know if we want to use something as low-tech as that. I think it should be a web page.
Well, we have the mailing list.
Yeah, I know.
Yeah, but the mailing list is ephemeral.
Right.
And, you know, I mean, I think to Kirk's point, I mean, I just got a cold call from Stack Overflow, which is now doing this whole careers thing because they can curate people who answer questions in certain areas and direct them to your job, and for the low price of $20,000, they'll list one of my job postings on there, and that kind of thing. That seems a little on the high side, but you know, I mean, iSystems is always hiring. I could certainly put a, I could put that to good use.
I think we would too.
So the point raised is that there are companies represented here who hire, and there are people at the conference who are looking for positions, and there are organizations out there that would like to extract maximal value from trying to connect to those two, and that value is perhaps more than is really sensible. And I think it's interesting that I actually know several people who have found new positions after conferences, or found FreeBSD using positions as a result of coming to a BSD conference. Maybe that's something to look at about sort of making a more explicit job session, recruiting session that could be attached to conferences like this.
I mean, we could have like a little job fair too, because I mean, Iceland is one company where they typically send a recruiter to BSDCon. So, I mean, that could be an opportunity.
Paul Vixie said something really interesting during his opening. Are you here, Paul? He said he picks up Linux people because that's what he can get. And I found that I pick up Linux people and make them FreeBSD people. I have exactly the opposite approach of, he's like, let them use the tool chain they want. And I just start giving them tasks that are FreeBSD specific.
So that's interesting. I think trying to force people into using FreeBSD is probably not the most effective way. But I think carefully guiding them. But paying them certainly works. but even still, I think a great counter to Paul Vixie's point is sort of I think we all know and truly believe that BSDs are great and the right way to get things done, and just allowing that to shine through to people is likely to get them to buy in as well.
So actually, just to follow up a bit on the job posting thing, I think the other reason why this might be a good foundation task is because, speaking as somebody who does a lot of hiring, has done a lot of hiring for a long time, non-curated job searches suck, right? This is why I pay tens of thousands of dollars to recruiters and placement firms, because they do the BOSO filtering for me. They do a lot of the resume screening and even some of the phone screens and stuff in some of the higher end cases, and that's invaluable, because if you just put something on Craigslist or right, you're going to get all kinds of, I saw a computer once and I would love your job. And so to get to my point, that if you could even increase the quality of the job listings to the point where you actually cross-reference the work that the person has done, if they're looking for local or remote, you would increase the pull substantially for people going to look at that page, because you've essentially done 9/10 of the legwork for them. They know if this is a kernel engineer or a jack of all trades. They have a live link to the work being done, so they can click and look at the code. I'd pay for that.
So Jordan's point is that a non-curated job matching is not very useful, given that there's a lot of low-quality applications that just really have no understanding of FreeBSD or kernel internals or whatnot, depending on what it is someone's looking for, and some sort of a role exists to more carefully match those, provide a venue where applicants, say, could provide links to their work or some demonstration of their history in the FreeBSD project, and they don't have to be a committer, but some way to sort of show their portfolio and work with people who are hiring to make that connection happen.
And you guys format it.
Yeah, I think.
Developers suck at self-promotion.
Yeah, I think it is. It's a little bit tricky. For the foundation to be in that role, but it is certainly something I think that is worth supporting in finding some way to support that sort of need. I think we're probably running short on time. The closing session, I think, is at.
Well, I think the break starts at 3.
Okay.
Yeah.
Okay, so we can go right till the end then, if there's any more questions. Yes.
Well, on our website, we list all the events we're going to be at. We post it on social media, and we publicize it in our newsletter.
And we got a nice shirt.
That's when we're there, yeah.
Is there a venue for that sort of information that you follow now that we're not on? Okay.
So that would be the foundation, and then I mean there's a event section on the freebsd.org. I don't think they keep it up to date as well, and that's one thing we're trying to help with is
Twitter, social media.
yeah.
Or BSD now.
I think that is a valuable comment, though. We are always interested in finding out about companies that use FreeBSD or individuals and or conferences that we should have a presence at. And so certainly I'm interested in hearing. I'm interested in that feedback coming to the foundation that says, there's this sort of open source conference. That isn't a BSD specific one, but really sounds like something FreeBSD people should be at, and having that information come back into us.
Right, and we are trying to work on that. We're actually trying to create sort of like a database of conferences that we think we should be at, and then also FreeBSD people who are in that region and know what their their focus or expertise may be on. So then maybe we could connect people at those conferences or to go to those conferences. We really want to get more FreeBSD people to give presentations. So we're trying to figure out a way to connect FreeBSD people with those conferences. I mean, Benedict right now, who's based in Germany, he's been trying to expand our reach in that area. And so he's, especially like at this conference, he's been talking to people about open source conferences. And so we're trying to do some of those. And we can't go to all of these, so we're trying to get people, the project people to actually go. And if it's and if it costs money and you can't afford it, we have the travel grant program too. Plus, we also provide material that you could print, you could translate. People have done that in, I believe, in Germany and France, and so we're really open to trying to help with those efforts.
I think we have time for one last question or comment from Colin. Yeah, certainly it's not lost on me that we've had a string of vendor or developer summits every month over the latter half of this year, and I think to some extent it sort of caught us by surprise, perhaps, in that we've often in the past, I don't think. We were happy to get a developer summit or a vendor summit to happen anywhere and at any time, and all of a sudden we've got more than we know what to do with, perhaps. So I think certainly trying to more carefully curate those summits, both in location and time, is perhaps sensible. One of the things I would like to see is a focus on various specific topics at different summits, so that someone who has a strong interest in networking, say, could know that, well, this one and this one are the two summits that I should really attend, and if someone's really interested in graphics, there's another one that they should go to. I think it's a little bit tricky still to really align the realities of people's travel schedule and availability with that, but I think it is certainly a valid point that we have a lot of summits this year, and allowing some sort of better planning, having them spread out to allow people who want to attend them to plan better is maybe something to look at. Other comments?
I would say it's a sign that the community is super healthy at the moment, because there are so many people doing these, and if there would be only that one conference in a year where BSD would be discussed, that would be a little bit of a sign that we are not doing so much for the BSD community. So the more conferences we have, or vendor summits, the better.
Yeah,
even if you cannot go to all of these.
It's a nice problem to have.
Yeah.
But I do think the idea of letting the summits say, this is what we're focusing on, because obviously you can't go to all of them, and I go to a particular summit, it's all about networking, but I mean, file systems are the only thing that matter in the world, so why would
All right, well, I think I won't keep you from the very important coffee prior to the closing session.
Stimulating closing session.
Yes. Thank you.
Thank you, everyone. Hey.
Here but one.
Yeah, she should just know.
Yes, I do, unfortunately.
Was there...
Yes, that's the goal.
How's it going?
Pretty well.
I felt like...
I do, yeah.
Conference like that was starting to kick in.
I am so tired.
Right about mid-afternoon.
To bring more on this event into focus more.
Question for you guys.
2 years to get ready for 2017 for SSH, SHA 2017 will be at the in Amsterdam.
Okay.
It will be
that was
the most part.
Especially the role of